Hello everyone, I welcome you to this amazing channel of PhysicsWallah English. So guys, today we are going to do sequence and series. This is the second lecture in our Champion Crash Course series. So, talking about importance of sequence series for JEE main, guys, you will see minimum 2 questions in almost every paper. Right? It will be very rare if you see only one question, but in general, we'll find 2 questions in the paper. Now, the majority of the questions are asked from simple properties of AP-GP, and the second most important section is sum of n terms. It might be a sigma related question, or it might be related to method of difference. Okay. So in today's lecture, we are going to do everything, every single concept, even if it is not there in JEE mains and it has some relevance with the chapter, we are going to cover it. Right. So starting with the flow of the lecture, this is how we are going to proceed. The first thing we'll be doing AP, GP, then HP. In AP and GP, I'll be teaching some properties also. Then we'll do some problems. After going for AP, GP and HP, we'll do some problems. Then we'll cover means. After that, the AGP series, then sigma notation, and then method of difference. Right? So the part which carries most weightage is this one, Arithmetic-Geometric Progression. The simple properties, like even if you have done NCRT, the NCRT level problems are also there in JEE mains. In recent years, I've seen one trend. The level of problems, it has been slightly up, right? Initially, what used to happen that the question will be 1 or 2 line, like the calculation used to be very less. But in recent papers, this is what I've observed. The questions are very calculative also sometimes. Okay. So let's start the session, guys. Let's start the session starting with AP. The definition of AP is that the difference of successive and preceding term is always constant, right? The APG sequence whose successive terms are obtained by adding a fixed number D to the preceding terms, and that fixed number D is called common difference. So if A is the first term, D is the common difference, this is how you write AP series, right? I hope you are aware of this definition. Obviously you will be aware. Okay, so in this you can see what we are saying, that if T1, T2, T3, T4, if T1, T2, T3, T4, if these are terms of AP, right? If these are terms of AP, then the difference, like T2 minus T1 will be equal to T3 minus T2 is equal to T4 minus T3. All these will be equal to common difference D. And that difference D and that D we call it the common difference for that AP. Okay. So now how do we write a general term of an AP? Guys, remember in this chapter, this general term is like going to come up for several number of times. And this particular term has the most importance also. You be it any problem from sigma notation or method of difference. Guys, if you don't know how to write a general term, you will be stuck forever in that problem. Okay. And see, general term is the most basic thing about a sequence. Okay. What is a general term? It is basically the pattern which entire series is following. So let me show you. We'll write the general term of AP. So let's say first term is A and the common difference is D. Okay, so T2 will be A plus D. Third term, A plus 2D. Now you can see the relation between this subscript 3 and this coefficient here. What will be T4? T4 will be A plus 3D. So can we say that if I want Rth term, it will be A plus R minus 1 into D. Correct or not? This is the Rth term. If you want any random term, put R equal to that value and you will get that Rth term. That is what general term is, the pattern. What is the pattern being followed by every term of the series? A plus D, A plus 2, A plus 3D. So you can see if it is X here, it is X minus 1. 3, 2, 4, 3. So this is the pattern being followed by every single term of the series. So this is the general term of AP. Now you are wondering that, sir, this is so simple, why are you explaining it? I wanted to explain it to show you one thing. See, let's replace R with N. So Tn will be something A plus N minus 1 into D. Now I can write it A plus N into D minus D. So this becomes N into D plus a minus d. So guys, can we say that this general term Tn is nothing but it is a function. It is a function of n. Can I say or not? An plus b, right? This is a linear expression in n. Sorry. So this general term is is equal to an plus b. Many times they will give you that Tn is an plus b, then find common difference first term. So if you have Tn given, then from Tn, what we can say, guys, what relation we can write here? You can see here, coefficient of n is common difference. Can you see? Coefficient of n is common difference. So this a will be common difference. This a will be common difference. And what will be that b? That b will be first term minus common difference. Right? Do remember it. You can see if you have a general term as a linear expression in n, then that sequence is going to be a AP sequence. Okay, so I hope this funda is clear. Let's move to the next point. Sum of first n terms of an AP. How do we find out? So Tn, let's suppose we have a AP sequence. We have a AP, as we have a AP, a plus d, a plus 2d, and we want n terms. So last nth term will be a plus n minus 1 to d. So we need to find out its sum. We need to find out Sn. So what is sum of n terms? Sum of n terms is equal to n by 2 into 2a plus n minus 1 into d. Most of you are aware of the formula, right? Also, this is known as Sn is equal to n by 2. This is first term, right? First term plus last term. This is also how you remember it. And how do we get this? How do we get this? This 2a, we can write it a plus n minus 1d, right? This expression we can write it as a plus n minus 1 into d. So this is a is first term, and what is this? This is the last term. So that is why we write it like this. Okay. So this is the sum of n terms. Now there is one more thing. There is one more thing, guys. In this result, just look at this result. In this result, if I multiply n inside, if I multiply this n inside this, then what is going to happen? Your Sn will be equal to, this will be 2 will cancel out, n into a plus, guys, I am multiplying n by 2 inside, n into a plus n square minus n by 2 into d. So what is it? What is it? What is it? This is d by 2 into n square, and then I can write it as, if I take n common, a minus d by 2 multiplied by n. A minus d by 2. What I wanted to show you, that sum of n terms of an AP can be written in the form of something like an square plus bn. If sum of n terms is in the form of an square plus bn, that will be definitely a AP sequence. Okay, and what is that coefficient a? Coefficient a is common difference by 2. That coefficient of n square, this is how you have to remember it. That coefficient of n square is equal to what? Coefficient n square is common difference by 2. Common difference by 2. Right? So that a is d by 2. That a is d by 2. This result you have to definitely remember. That a is d by 2. Okay, so if they give you directly sum of n terms ka expression, you can always find out what is the common difference of that sequence. I hope my points are clear, and these are like very basic, so let's not waste time. So what is the important information? This is the important information here, and this as well. Okay, moving to the next point. So this is what we discussed, that nth term of an AP is of the form an plus b, a linear expression in n such that the coefficient of n is the common difference of the AP. Okay, we discussed this point. Let's move to the next point. Sum of first n terms of is of the form an square plus bn. That is what we just discussed. Got a tick? Okay. Now this is, see, this is not just valid for a AP. This is valid for every single series. This is valid for every single series in the world. How I'm saying so? See, I don't know what is the pattern followed by the sequence. I'm going to just simply write it. Okay, I'm going to write that series T1 plus T2 plus T3 plus T4 Tn minus 1 Tn. Okay, what did I do? I simply wrote all the terms. I wanted to find Sn, sum of n terms. I wrote all the terms. Okay, now what if I consider only n minus 1 terms of the sequence? So it will be T1 plus T2 plus T3 plus T4 up to Tn minus 1. So now if I subtract them, guys, what will happen? If I subtract them, you can clearly see now this will be Sn minus Sn minus 1 equal to, this will cancel out, this will cancel out, all these terms will cancel out. What is going to remain? Only Tn. And that Tn is the general term of that sequence. So if you are given with sum of n terms, you can always find out the pattern followed by that series. You can find out what is Tn. Clear? Okay, let's move to the next properties of AP. Now we'll discuss some properties of AP. The first property, the first term and common difference can be 0, positive, negative, right? Anything you want, you can take it. Okay, any real value. If it is like 0, 0, 0, this is also AP, right? You can consider this is also AP. Common difference can be 0. If you write 1, 1, 1, 1, this is also AP. No problem in that. Okay, the only definition it has to follow is that difference. The difference has to be constant, right? Then I come to the next point. ABs are in AP, then 2B equal to A plus C. One of the most used results, and also, right, if you say that ABC is in AP, then obviously guys B minus A will be equal to C minus B. So we'll have 2B equal to A plus C, right? 2B equal to A plus C, simple property. Let's get moving. 3 numbers in AP, take it like this. If we have 4 numbers in AP, this is how you take it. Now why this is specifically mentioned, guys? Because in questions what you will come across, 3 terms are in AP and their addition is something given. Okay, 4 terms are in AP and their sum is something X. So if you consider terms like this, A minus D, A plus D, you see when you add them, you get only A. So this is just like to minimize some calculation steps. There is not a rocket science behind it. This is only to minimize your calculation steps. Okay, so I hope this is clear. So remember it, when you have odd number of terms, consider common difference as the value D. Like you can see here, A minus D, then A plus D. If you have even number of terms, consider common difference as 2D. Like here, A minus 3D, A minus D, A plus D, A plus 3D. Now don't ask, sir, how can we take common difference 2D? The common difference D. Why, that 2D is a new D for you. That 2D value is the new common difference for you. Don't think like that. Okay, so these two are obviously like helpful in problems. 3 numbers, these 3, 4 numbers, A minus 3D, A minus D, A plus D, A plus 3D. Okay, so let's continue, guys. Property number 4, some of the terms equidistant from beginning and end are always equal, and this is used to find out that Sn formula. Let me show you. I am going to write the series. See, so Sn was A plus D, then A plus 2D, right? And the last term was A plus n minus 1 into D. Now the same sequence I am going to write, but in reverse order. I am going to write the last term first. So what will be it? A plus n minus 1 into D, A plus n minus 2 into D, and this will keep on going. The last term will be A. Now guys, just look at this. This is first term from the end. This is first term from the beginning. This is first term from the end. Add these two. What is their sum? 2A plus n minus 1 into D. This is second term from the beginning, and this is second term from the end. Right? This is our original series. So this term was second term from the beginning, and that is second term from the end. Add them. If you add them, guys, what do you get? Same. 2a plus n minus 1 into d. That is what I wanted to show you, that using this only we prove it. This is also 2a plus n minus 1 d. This is the last term from the beginning, and this is the last term from the end. Okay, you see the every term has same sum. Is that clear? Is that clear? And this is the one of the most asked result in the exam. Okay, what they will give you? They'll give you some combination such that you can find out a1 plus al. Okay guys, so I hope you are able to understand here that t1 plus tn is equal to t2 plus tn minus 1 is equal to t3 plus tn minus 2, and so on, right? This is the property. And see, the one way to identify is that, you see, sum of the subscript is n plus 1, n plus 1, n plus 1, n plus 1, n plus 1. So this is how you can identify. If the sum of subscripts are equal, their sum has to be equal. Clear? So I hope you have understood this property, and I'm going to show you the application also very soon with the help of problems. Moving on, boys. Each sum of is increase, decrease, multiply, divided. Obviously, the resulting sequence is not going to change. This will remain AP. Now, how is this true? How the sequence is not going to change? You can do it yourself. Consider AP A plus D, A plus 2D, and so on. So if you multiply K, like KA plus KD, K plus 2KD, so you can see this is still in AP. And what is common difference? Like here, common difference was D, here it is K into D. The common difference also got multiplied by K. If you divide it like A by K plus D by K, will it matter? Still not. Now the common difference will be D by K. Okay, if you add some number, let's say A plus K, A plus D plus K, again there is no difference. The common difference here is still same, it is D. So that is how you can write different series, and whatever they are saying you can do it on your own and you can prove it yourself. Otherwise, I hope it should be clear, right? Okay. Kth term from the last is equal to n minus k plus 1 term from the beginning. That is the counting, guys. That is the counting. Kth term from the last. Like, see, this is T1. Suppose this is a sequence T1 plus T2 plus T3. This is a series here. This is a series. This is a AP series. So it says that kth term from the last. So let's say k is equal to 2. So second term, okay, sorry, from the last they are saying. Okay. So let's consider Tn minus 1. Okay. So Tn minus 1 is the second term from the last. So k is 2, guys. So second term from the last is equal to n minus 1 term from the beginning. That is what we have. This is n minus 1 term. Second term from the end is equal to n minus 1 term from the beginning. That is how you have to remember it. If you want kth term from the end, you find out n minus k plus 1 term from the beginning. That is how we have to use it. Kth term from the end will be n minus k plus 1 term from the beginning. Okay. And see, if you forget this point, no problem. If they want some term from the end, reverse that series. Write the series in reverse way and find that term from the beginning. Okay, fine. Let's get to next point. Any term on f except the first is equal to half the sum of terms which are equidistant from it. Right, that this is almost just we proved. Let me show you. A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, and so on. So consider A plus 3D, right? And consider two equidistant terms. So two equidistant terms, let's say this is A, one is A, and the other one will be how much? The other one will be A plus 6D, right? Equidistant, like 3 terms here and 3 terms in the right. So what is this sum? A plus 6D divide by 2. What do you get? A plus 3D. That is what we had to prove here. Is that clear? Obviously, right? Obviously, because will be having same difference of D there. 6D minus 3D, it is 3D. It is also 3D. So that is why this property holds. Even if you forget it, no problem. Okay, no problem with that. Okay guys, so let's start GP now. So in geometric progression, we know the thing here that the ratio of succeeding to preceding is always constant. And that constant ratio is known as common ratio for the sequence. Right? For example, if we have something like 2, 6, 18, 54. Now this is GP whose common ratio is 3. Right? If we can write like something 1 by 2, then 1 by 4, 1 by 8. This is GP. Common ratio is how much? 1 upon 2. You just keep dividing. 6 upon 2 is 3. 18 by 6 is 3. This is 3. 1 by 2, 1 by 2. Okay. The ratio of preceding to succeeding is constant. And succeeding to preceding is constant. That is also constant. But the common ratio is known as the ratio of succeeding to preceding. Okay. So, like all of you know how we write in general a GP series. Let's say we first term, we assume that first term is A and the common ratio. And the common ratio is equal to R. So we can write the sequence A, AR, AR square and so on. What you should definitely remember is the fact that the common in the GP sequence, A cannot be 0. The first term cannot be 0 and also the common ratio cannot be 0. A cannot be 0, R cannot be 0. Apart from 0, you can take it any like real value. Like you have seen in case of AP 1, 1, 1, 1, it is a AP, right? Or 0, 0, 0, 0, it is an AP. But if you write 0, 0, 0, that is not GP. If you write 1, 1, 1, you can consider it GP sequence also, right? Because the ratio is constant. But the first term or the common ratio, it cannot be equal to 0. That is the point you should definitely keep in your mind. Okay. So moving on, now how to write general term of a GP, how to find out that pattern. So see, we assume that first term is A, and the second term will be A into common ratio R, third term will be AR square, fourth term will be AR cube. So you can see the relation between this subscript here and this number here. So what will be any general term? Like if I want to write Tn, that will be A into R to the power n minus 1. This is the pattern followed by entire sequence. And if you want to write any particular term of the sequence, what to do? Just type put there in the stead of n value. Clear? Simple thing. Tn equal to A into R to the power n minus 1. Moving on. Sum of first n terms. Now this result, guys, is very, very important, right? R power n minus 1 upon R minus 1 or 1 minus R power n upon 1 minus R doesn't make a difference. Okay. What you have to see here, this formula is applicable if only R is not equal to 1. What is happening when R is equal to 1? Guys, if R becomes equal to 1, then you put it here, 0 by 0. It will be having an undefined form. It will take an undefined form. So that is why this formula is only valid for R not equal to 1. Like see, if R is equal to 1, all the terms are equal, you can add them in a very simpler way. Okay, so this is the first, this is the formula. And if you want to understand like how do we get to this result, it's very simple. Like we write Sn equal to A plus AR, AR square, AR cube up to A to the power n minus 1. Then we multiply this sequence by R. It will be AR, AR square, AR cube, and this will go on. The last term will become AR per n. So now when you subtract them, so Sn into 1 minus R will be equal to, you see, the alternate terms, these terms will cancel out. Only the least, or like these two will not have any pair. So A 1 minus R to the power n. This term and this term will be subtracted. So what is that sum of n terms? We have a formula here, 1 minus R to the power n divided by 1 minus R. Now obviously you don't need to remember the formula. What you need to remember is the result. Okay. Now, in the same one, this is equally important. Sum of infinite number of terms of a GP. What is that? It is A upon 1 minus R. Sum of infinite terms is A upon 1 minus R, but there is a result written with it. Mod of R should be less than 1. Now, what exactly this mean? What exactly is the meaning of this thing? See, suppose if I write a sequence AR, AR square up to infinity, and R is greater than 1 or R is less than minus 1. Then you see this R will keep on increasing. This R will keep on increasing. AR cube power 4, 4000, 4 crore. It will keep on increasing. So that R power infinity, right? That R power infinity will tend towards infinity. Now what is the problem with this? The sum will become undefined. If you are getting sum at something infinity, so that sum is definitely not defined. So this is the issue. That is the problem. So if we keep R between minus 1 to 1, we know that any number, right? Any number between minus 1 to 1 raised to the power infinity is 0. Any number between minus 1 to 1 raised to the power infinity will be equal to 0. Now this will help in the convergence of the series and will have a result like here. So what was sum of n terms, guys? Sum of n terms was a into 1 minus r power n divided by 1 minus r. So when n tends to infinity and r is something between minus 1 to 1, right, except 0, obviously not 0 also, and r is not equal to 0. Now in this case what is going to happen? You put it here, so that r power n will tend to 0. So this s infinity comes out to be a upon 1 minus r. Okay, so very important result. You have to remember it. You have to remember it that sum of infinity is a upon 1 minus r, but with a condition r should not be greater than 1 or should not be lesser than minus 1. Okay, fine. Now just like we did some full properties of AP, we'll see some properties of GP also. The first one being ABs are in GP, B square equal to AC. Obviously here B by A will be equal to C upon B, right? So B square will be AC. 3 conjugate terms. In case of AP, they'll talk about sum. In case of GP, mostly they'll talk about product. So you see, if you take terms like this, A by R, A, AR, they are in GP and the product of all three is only A cube. The R is eliminated. So it will save some steps in calculation. That is why this is how we have to assume. If we have 4 terms, it is A upon R cube. Just like that, in AP we used to follow. If there are even number of terms, 2D. If there are odd number of terms, D. Just like then same thing is here also. If you have even terms, you will consider R square. You can see here common difference is R square. And if you have odd number of terms, it will be R. But that is how you write it. Okay, fine. Moving to next point. If each sum of GP be multiplied divided by the same, the resultant is also GP. Okay, the multiplication division. We cannot say anything about addition subtraction. If you multiply or divide something, the resulting sequence will still be at GP. Still will be GP. Each sum of GP be raised to the same power. It is also GP. Like this is obviously clear. Like A power n, then A power n, R power n, A power n, R power 2n, A power n, R power 3n. Like this is also GP. Right? What is that common ratio? You see, common ratio will be R power n. This common ratio becomes R power n. But the resulting sequence is still GP. So if you raise that to some power n, it will be a GP. Okay? Okay guys, so moving to next property. If in a GP the product of two terms which are equidistant from the first and the last term is constant and is equal to the product of first and last term, right? I think this if is useless. It should be only in a GP. In a GP, the product of two terms which are equidistant from the last. Now this is obviously, right? Why? I'll show you. I'll write some terms here for you. Let's say AR square, AR cube. Last few terms, AR to the power n minus 3, AR to the power n minus 2, AR to the power n minus 1. So what is the property saying? That consider two terms which are equidistant from the beginning and end also. Let's say I consider second term from beginning, which is AR, and second term from end. What is that? Second term from end, which is, it is A into R to the power n minus 2. Multiply them. If you multiply them, the product is equal to A square R to the power n minus 1. And what is this equal to? This is product of first and the last term. Is that clear? It is always going to be the first and the last term, right? This is what the property meant. If you have two terms equidistant from beginning and end, the product will be always equal to the first and the last. Clear? Now the next property, what does it say? TR square is equal to TR minus K, TR plus K. See, it meant that like you consider any rth term from here. Let's say I consider third AR cube. This is a fourth term. Okay. So now what you do? You consider few terms, right, at distance K in the left and the right. Consider two terms in the left and in the right at equal distance K. So, right. So from here I consider two term from the right, which is AR power 5, and two term from the left, that is AR. Now what is this equal to? This is A square R power 6, which is exactly equal to square of it. Now why is this happening, guys? Because that sequence itself has formed a GP. You can see if you take out the terms AR cube and AR power 5, what is it? It is the GP, and the common ratio will be decided by that factor K. Two terms you are taking, R square. Differences of three terms, R cube. Four terms, R power 4, and it will keep on increasing. Okay, so I hope you got this point. Right. Moving on. If the terms of a given GP are chosen regular intervals, the new sequence is also GP. That is what we just discussed. If you take it regular intervals, it will be a GP. Then, even if you have GP of positive, then the log of them will be AP. Obviously, right? Obviously, if you take, like, suppose if the terms are, considering domain is there valid, AR square, AR cube. So if you take log here, it will be log of A. Log of AR will be log of A plus log of R. This will become log of A and plus log of R square, which will be twice of log R. What is this, guys? This is GP. This is a AP. This is a AP whose common difference is, this becomes an AP whose common difference is nothing but logarithm of R. The common difference becomes log of R. Clear? I hope you understood this point. Let's move to next one. So if A1, A2, A3, B1 are two GPs, then you take the corresponding terms product or divide them, that will be also GP. You can write 2 GP and you can see it on your own. There is nothing special about it. Okay. Then the least used harmonic progression in, this is the least used progression in JEE main. Okay. Let's at least understand the definition properly. And it's very simple that if few terms, okay, if the sequence is HP, then the reciprocal will AP. That's it. If you have any question related to HP, you don't need to solve an HP. What you have to do, take reciprocal, consider the AP and solve it. That is what you have to do, right? Take reciprocal, make it a AP sequence, and then do whatever you want to do. Okay. Like, see, if I say that 1, 2, 3, 4, 5, this is AP. So 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5, that will be HP sequence, right? So only one funda, terms are given in HP, take reciprocal, make AP and solve. Fine. No term of an HP can be 0, right? Because we are having the game of reciprocal, obviously it cannot be 0. And if 3 terms are in HP, then B is having this relation. How? Let's prove it quickly. Let's prove it, guys. So if A, B, C is in HP, then 1 by A, 1 by B, 1 by C will be AP. So I can definitely say that 2 upon B will be equal to 1 upon A plus 1 upon C. So what is that B equal to? That 1 by B is equal to A plus C divided by AC 2. Then B becomes equal to 2AC divided by A plus C. So you need to remember this result at least. Like you remember for AP. If ABC AP, 2B equal to A plus C. ABC GP, B square equal to AC. ABC HP, B equal to 2AC upon A plus C. These three results should be on your fingertips. Okay. Let's solve few questions. Let's solve few PYQs. Most of these questions are from previous year. So you will see what level of problems we are dealing with. And I told you that in recent years, the level has slightly increased. The pattern of the questions every year is same. Okay, they are going to ask from like consideration of terms in AP, GP. The difficulty level, it keeps varying. So let's solve few problems. The first one being 9 into 25 A square, B square equal to this. Now, if you see all these terms, right, and here comes that result of sum of squares, which have been like shouting for so many lectures that remember it, you will see the use here. Okay, what exactly this series? This is 15A square. The next one is 3B square plus then 5C square minus this is 15A into 3B minus 3B into 5C and minus 15A into 5C into 5C equal to 0. This is it. This is what the series is been given as. You can clearly see 25 into 9 A square, B square. This is how the series has been given. So what is it? I think after I've written it like this will strike this result to you. That A square, B square, C square minus AB minus BC minus AC. If it is 0, if this is 0, in that case we consider ABC equal. Right? This is the result which I am going to use. So here I can write 15A will be equal to 3B will be equal to 5. So let's consider this all thing is equal to lambda. And to simplify, let's consider it to be 15 lambda. Why I'm taking as 15 lambda? Because everything is in multiples of 3 and 5. It will help me have ABC, no? Like so easier way to calculate. So what is A guys from here? A will be equal to, this A will be equal to lambda. What is B from here? 5 lambda. And what is C from here? 3 lambda. Now, can you see guys, what is happening here? 2C is equal to A plus B. How easy this has become? 2C equal to A plus B. So if 2C is equal to A plus B, that means A, C, B are in AP. AC, B, C and A are in AP. D is the correct option. D is the correct option. Clear? This is what we had to use here. I hope you have understood this. Let's solve next one. Okay. So what is the question here? A1 into A3 be in AP. A3 plus A7 plus 11 A15 is 72. Sum of its first 17 terms. Right? So sum of first 17 terms will be equal to 17 by 2. Then first term plus 17 term. This is the result. Right? Now just look at that info given. And I told you one result of AP. Sum of terms equidistant from beginning and end are equal. Right? So, and that how to decide? You just add subscript. If they are equal, if the addition is equal for like different pairs, they are going to be equal in sum. So this 3 plus 15, 18, 7, 11, 18, 17, 1, 18. So what is this basically? This is nothing but like this is A3 plus A15 plus A7 plus A11 is equal to 72. So I can replace these two with A1 plus A17. Right? So I can write this as twice of A1 plus A17 is equal to 72. I'll get A1 plus A17 as 36 and use that value here. So it will be equal to 17 by 2 into 36. This will cancel out. So 17 into 18, what will be it? I think it will be 306. Clear, guys? So this is how the property has been used. And don't panic if you like, if you don't remember, can we not solve it? You can solve it. What to do? AP. See, in any problem AP, if you follow the basic of the basics, like the first term is A, then A plus D, A plus 2D, A plus 3D, A plus 4D, you do that, you substitute it, and you are going to get answer. Right? There is no need of any result. You can always get answer. Let's solve next. A, B, C with the three distinct real numbers in GP. A plus B plus C is X, then X cannot be. Excellent question. This is like by far one of the best questions of AP, sorry, GP in like last previous year question. Not that difficult, but the concept is fine. See, A plus B plus C is given X times B. What else is given? What else is given? What is given? X cannot be. What X cannot be? ABC is real. ABC is three distinct real values. So, since ABC are in AP, so I'm going to replace B with AR, C with AR square. B is nothing but A into R. A cancels out, right? We have a simple equation. R square plus 1 minus X times R plus 1 equal to 0. Now, if ABC are real, then R has to be also real. Got the point? If ABC is real, then that common ratio also has to be real. So, discriminant has to be greater than 0. So, if D is greater than 0, B square is greater than 4AC. B square is greater than 4AC. Which of these options will not satisfy? You put 4 satisfying, minus 3, minus 2. This D option is not satisfying because you put 2 here, it becomes 1 greater than 4, which is completely bakwas. So the answer will be this D option. So what is X? X cannot be 2. Clear? So the slightly unique, right? It's not only about AP, GP, sum, slightly different. Let's solve next. A, B, C with the 7th, 11th, 13th terms respectively for non-constant AP. Okay. A, B, C with the 7th. These terms are also conjugated terms of a GP. Now this is the problem. See, this is very, very important and repetitive. Okay. Like many questions of the same type has been there in previous years also. One of the hot topics kind of in GP problems. So let's solve. So A is equal to 7th, 11th and 13th term of a AP. So this is A plus 6D. B will be equal to A plus 11th term, 10 into D. And C is A plus 13th term, 12D. And these all are conjugative terms of GP. So can I say that this will be equal to, if this is A, then this will be AR and this will be AR square. Right? Let's write it like this. AR square. Now equation 1, equation 2, equation 3. What are they asking? Find A upon C. So if you find A upon C, you find A upon AR square. So that is they basically want what is value of 1 upon R square. That is what they are interested in. They want us to find out 1 upon R square. We'll find it. We'll find it. We are pro at these things. We are pro. So I need to subtract 2 from 1. A will subtract. You will have 4D is equal to A times R minus 1, equation 4. Then subtract 3. Then subtract 2 from 3. So 12 minus 10. 2D is equal to AR times R minus 1, equation 5. Right? Subtract these two. A will cancel out. 2D, AR, R minus 1. Now divide them. Divide 4 and 5. If you divide 4 and 5, 4D by 2D will be 2 and this will be 1 upon R. Guys, we directly got value of 1 upon R, which is 2. So 1 upon R is 2, 1 upon R square will be 4. That's it. That's it. How simple this question is. And one of the most frequent problems in for JEE mains. I hope you have understood the solution, guys. Okay, let's solve next one. Now, the sum of an infinite geometric series with positive terms is 3. Okay, so a upon 1 minus r is given 3, and sum of the cubes of its term is 27 by 19. Okay, sum of cubes, what will be the series? Like a cube, ar cube, ar square cube. The common ratio will be r cube now, right? The common ratio will be r cube. So what is it? 1 minus r cube is equal to 27 by 19. Then a common ratio of this series is, we have to find out r. So let's substitute a from here. Like a is 3 times 1 minus r. Let's replace it here. Let's replace it here. This is 27 into 1 minus r whole cube, divide by, factorize. 1 minus r, 1 plus r square is equal to 27 divided by 19. So this 27 will cancel out. 1 minus r will also cancel out. This will be 2 now. So 19 minus 19 r square. 19 plus 19 r square minus 38 r will be equal to 1 plus r square. Right? Just cross multiply. So in the numerator we have 1 minus r square, and the denominator is simply 1 plus r square. Now let's play with it. 18 plus 18r square and minus 38r, and this will be minus 39r equal to 0. Factorize, guys. With 3 we can do. So 6 plus 6r square minus 13r equal to 0. So 6r square minus 13r plus 6 equal to 0. This is the quadratic we have got, right? So what are the factors? 9 and 4. 9 and 4 are the factors. Let's factorize. So 6r square minus 9r minus 4r plus 6 equal to 0. What can I take common from here? 3r. So r minus 3 minus 2, r minus 3 equal to 0. So either r is 3 or r is 2 by 3. Getting my point? Getting my point? R is 3. I think this is 2r, right? 2r, sorry. 2r. So r is either 3 by 2 or 2 by 3. Now this is the infinite GP. If this is infinite GP, right? If we are dealing with an infinite GP, then r has to be between minus 1 to 1. So the only answer will be r equal to 2 by 3. 2 by 3 is the correct answer. Which one is that? Option C. Right? Simple problem. Again, you can observe that in most of the problems it is formula based. And if terms are not known, we just assume you have the general like sequence of terms known for AP, for GP both. So we are just writing terms and simplifying it. Okay, let's solve next one. Now what is the question here? Let's read it. 19th term of a non-zero AP is 0. 19th term, right? That means A plus 18D is 0. Then the ratio of its 49th term, 29th term. 49 divided by 20. Now how simple is this? So T49 will be A plus 48D and A plus 28D. We have the relation of A. A is minus 18D. So minus 18D plus 48D divided by minus 18D plus 28D. That is 30 divided by this is 10. So it is 3. Answer is, this will be 3:1. How simple is this? How simple is this? You're very lucky if you have these type of problems in exam. Like this type of are very rare now. Okay. Next one. The product of 3 consecutive terms of a GP is 512. So I'll consider terms as A by R, A and AR. Right? This is the terms I'm considering. And their product is 512. So AQ will be equal to 512. And from here, we have the value with us is 8. And that gives us the sequence 8 upon R, 8, 8R. What is next? If 4 is added to the each of the first and second of the term, the three terms are now form an AP. If 4 is added, okay, 4 is added to first and second term. 8 by R plus 4, 8 plus 4, 12, 8R. Now this becomes GP, right? This is what written. This becomes an AP, guys. This becomes an AP. Okay, if you add 4, these terms will form an AP sequence. What is next? The three terms now form an AP. The sum of the original three terms of the given GPs. So we had to find out what is A by R plus A plus AR. So A is known. A is known. Now to find out that sum, we need to find out R also. Let's solve that equation because it's in GP. It is in GP. It is in GP. So 24. 2B is equal to A plus C. So 8R plus 8 by R plus 4. So we can take 4 common. So this is 6 equal to 2R plus 2 by R plus 1. So we have 2R plus 2 by R equal to 5. Right? So one value we can clearly like see from here is 1 upon 2, right? 1 upon 2. R equal to 1 upon 2 is an answer. What is the other one? 1 upon 2 and I think we need to solve for the other one. What is it? It is 2R square minus 5R plus 2 equal to 0. So this is basically 2R minus 1 into R minus 2. 0. So R is 1 upon 2 and 2. Right? So if you got values of R terms, what will be GP terms? You push it here. GP terms will be A is 8. So let's put R equal to 2. For R equal to 2, what will be terms? 8 by 2, 4. 4, 8 and 16. Right? So 16, 8. This is 28. D is the correct option. This sum is equal to 28. And these are the type of problems you will face in number, in a huge number in these exams. And you see, it's nothing but the framing equation, the framing of all the equations. And this feels like some like class 8, class 9 type problem. There is not much thinking involved. Whatever information is given, just use that. It's so simple, right? It's like solving linear equation. Okay, guys. So let's solve next one. What is the question now? Let's read it. Sum of the first n terms of a non-constant AP is given. Okay. So sum of n terms. Sum of n terms is given 50n plus n square. A times n square by 2 minus 7a by 2 times n. If D is the common difference of this AP, then order pair D comma A50. Okay. So this is based on the like some properties we had written, that sum of n terms can be written as an square plus b. Okay. So if you write it properly, this is a by 2 times n square. Right. This is a by 2 times n square plus 50 minus 7a by 2 times n. This is what we have. Now, what is that? If you compare it with the original formula, what was the original formula, guys? What was the original formula? Sn was d by 2 times n square plus a minus d by 2 times n. That is what we had, right? A minus d by 2 times n. I think that is what we had here. So d by 2, a minus d by 2. Okay. So D is A. We can clearly see if you compare now, right? We can compare. So D, the common difference is A, and the second is this A minus D by 2. So A minus D by 2 is equal to how much? 50 minus 7A by 2. So D is known A. So A minus A by 2 is equal to 50 minus 7A by 2. So what will be small a? What is the first term? Put it there. So 50 minus 6a by 2, 50 minus 3a. So we got first term, we got common difference. What are they asking? They are asking the common difference and the 50th term. So guys, what will be A50? A50 will be, the first term is this 50 minus 3A plus 49D. So 49A. So what is it? This is 46A plus 50. So this is the correct option. A is the correct one. A comma 50 plus 46A. Clear? I hope you got this. Let's do the next one. Sn denotes the sum of the first n terms of an AP. S4 is 16, S6 is minus 48, S10 is equal to. Right? Sum of information. What information is given? S4. And now we are dealing with AP. N terms in AP. So S4 is given. So what I can say? Like 4 by 2 A1 plus A3 is equal, A1 plus A4 is equal to 16, and S6 is also given. So I think let's do everything in terms of A and D. This becomes again like we have to frame equation and then solve. There is nothing special about it. There is nothing special about it. We have a data given. Based on that data, we can frame equation. We can find unknowns. This is class 8 stuff, guys. So S4 is 16. So 4 by 2 into 2A plus n minus 1. So n minus 1 is 3. 2A plus 3D is equal to 60. Right? So this is the first equation. 2A plus 3D equal to, this is 2. Cancels out 8. 8. Equation 1. Now the second one is S6 is minus 48. So 6 by 2. 2A plus 5D is minus 48. This is 3. 3 cancels out minus 16. So 2A plus 5D is equal to minus 16. So you have equation 1, you have equation 2. Find A, find D. Use the formula for S10, which is 10 by 2, A plus 2A plus 9D. How simple is that? It's not even, it's an 8th class stuff, guys. Next one. The number of terms common to the two APs. Excellent question. Now this is what is the trending nowadays in JEE main. Okay, this is a kind of trending question. So how to find out those common terms? You see, I'll let you know one funda here. Remember, when you are dealing with 2, 3, 4 APs and you want to find out the common difference of the common AP, it is always LCM of all the common difference. Okay, like here, if I see the series, the one AP, the first AP one is 3, 7, 11 up to 407. This is not 407, it's up to 407. Like 15, 19, 23 up to 407. The second AP is 2, 9, 16. So 2, 9, 16, 23, and this is up to 709. Now these two AP, if you want a common AP out of these, now for that common AP, so for that common AP, the common difference will be LCM of D1, D2, right? Let's say D1 is common difference for this, D2 is common difference for the second one, and D1 is 4 and this D2 is 7. So which is equal to LCM of 4 and 7, and that gives us 28. Okay, so 28 is the common difference for that common terms Wallah AP. Okay, we got. Now we need first term also, and I think if you have given, God has given 2 eyes, you can see 23, 23. Okay, so this is your common term. So the common AP will be something like this: 23, 23 plus 28, 51, 51 plus 28. It will be 79 and so on. But what we have to find out? Common terms, right? We are finding common terms. So it should not exceed the lesser value of these two, the least value of these two. Sorry, that is the 407. It cannot exceed 407. What will write? TN for this AP should be less than or equal to 407. TN should be less than or equal to 407. To see how many terms exist here. So TN will be 23 plus n minus 1 into D, 28 is less than 407. When you simplify it, guys, when you simplify it, this comes out as n less than like 14 point something. So this gives us answer n will be equal to 14. There will be 14 common terms for these two AP. So this is very important step here. Okay. See here, the first term was very easy to figure out. Otherwise, for that also it would require some some exercise of mind. Otherwise, the problems are going to be this simple if you have knowledge about this funda. Clear? Okay. So let's solve the next one, guys. What is it? Given an AP whose terms are all positive integers, okay, the sum of its first 9 terms is greater than 200. Sum of 9 terms is greater than 200 and less than 220. S9 is less than 220. Fine. Second term is given 12. Okay. Second term. So let's say A plus D is 12. See, if they have given AP, I have started with always A plus D, A plus 2D. I don't think anything else. If it is AP, terms are not given. I know what is it. A plus D, A plus 2D and all. Okay. So let's simplify it and find out D. This is why this equation is given, to find out that D. Let's find out. Let's find out, guys. So sum of 9 terms. Okay, that is what is given. Sum of first 9 terms. So 9 by 2, 2A plus 9 minus 1, 8D. This is greater than 200. Greater than 200. Okay, there is no equality, right? There is no equality. So let's remove that equality sign. And less than 220. So this will be 200 by 9. So 200 by 9 is less than. This is 2. This is A plus 4D. So A plus 4D we can write. A plus D is 12. It will be 12 plus 3D. And less than 220 divided by 9. So 12 plus 3D is greater than. Now 1200 by 9. What is it, guys? This is 9 to 18, 22 point something, right? 9 to 18 to 22.2 something. Okay. And what about here? This is 9, 4, 36, 24.4 and so on. So this 3D value will be greater than something 10.2 and less than 12.4. When you divide D, when you divide 3, this is like 3 point something and this is less than 4 point something. So this clearly says, since D is an integer, why? Because all the terms are positive integers. So without any doubt, this D will be equal to 4. And this is how, see, if they don't give direct problems, but the method of giving information is also too direct, right? So D becomes equal to 4. A is known. A plus D is known. A plus D was 12 and D is 4. So now we have A also. A is 8. Now the GP is AP is complete. A is 8, D is 4. Which we want? We want fourth term. So that will be 20. Okay. Like this was very simple problem. Like see, most of the problems that you have been dealing with in exam is, it's only like the information you have to gather and then you have to just implement it to like solve the different equations. Okay, next question. What are the standard types of problem? What are the standard types of problem like in any book or anywhere you see? And this was asked in JEE. I hope you know the method here. 0.7, 77, 777. So this is nothing but, and how many terms you want? 20 terms. So this S20 will be equal to, guys, what is it? What is it? Take 7 common and this will form a GP. Like 1 by 10, 11 by 10, triple 11 by 11 by 100, then triple 11 by 1000 and so on. Up to 20 terms. Okay. Then what we can do? What we have to do in these type of problems? We have to multiply and divide 9. So this becomes 7 by 9. Now this is 9 by 10. 99 by 100. Then 999 by 1000 and the other terms. This is what it will become. Now we have a scope of forming GP here. Initially it is not GP, right? This is just a sequence. Is there anything mentioned? No, but we can convert this sequence into a GP1. This is how. Multiply 9, divide 9. Now write that 9 by 10 as 1 minus 1 by 10, 1 minus 1 by 100, and so on. This is it. There are 20 terms. So 1 will be added 20 times and minus. Then you have a GP 1 by 10, 1 by 10 square, 1 by 10 cube, 1 by 10 power 20. And the rest I leave up to you. Now this is nothing but a simple GP to solve, right? This is nothing left. I will solve for one more step. This is 20 minus, guys. If you solve it, this is A into 1 minus R to the power N divided by 1 minus 1 by R. The rest calculation I leave it to you. Solve it. I think you will get C or A. This is what you will get. Just some now simple multiplication. From this problem, what I wanted to teach you, this is a very old problem. Still I have taken it only to show you this step. Like this is how this gets converted into a GP sequence. These 3 steps. That is all you have to keep in mind. Okay. Moving on to next question. Let n be the nth term of a GP of positive terms. N equal to 100 is 200. Okay. So if you put n equal to 1 here, let's write the information given. Let's extract it. So if you put n equal to 1 here, so what is become? This will be A3. So A3, then A5, and that makes it up to A201. This is equal to 200. Fine. Now the second one, A2 plus A4 up to A200 is equal to 100, right? Then you have to find out what is A1 to A200. This is what they are asking, right? If you put here n values, what is A1 plus A2 up to A200, right? So if we add, you see A1 is missing, but A201 is extra. A1 is missing and A201 is extra. So the information has been given in so symmetric way that the calculation, you see, it won't take time. Like A3. So this is a GP. Obviously, I am starting with the fact that a GP. So I am going to consider AR square and so on. This is GP. I am going to consider it. I'll put all these values in these equations. I'm going to put all these values in the given equation. If I put it in the first equation, A3, A5, A201, so A3 will be what? AR square, AR power 4, up to AR power, this will be 200. This is 200. Equation 1. Now in the second one, A2 will be AR plus AR cube up to AR power 199. That is 100. Equation 2. So guys, you can see if I divide it, you see if I take AR square common from here, so if I divide it, if I divide 1 by 2, 1 divided by 2, this gives me R equal to 2. Common ratio will get, if you divide these two equations, take AR square common, take AR common, we have equal number of terms, and divide, we'll get R equal to 2. So once we have the R value, now we need to have the first term also. What is first term, guys? What is first term? The first term, what is the first term here, guys? AR square. So let's substitute this in the first equation. Let's substitute this in first equation and let's try to find out what is the value of A. So this is A into, so the first equation. This will be AR square multiplied by how many terms are here? Like the common ratio is R square here. So R square to the power 100 minus 1 divided by R square minus 1. This is equal to 200. Right? We just substituted these values here. Now A is not known but R is known. R is 4. R is 2. So this is A into R square will be 2 square 4 divide by 3 into, I can write it as 2 to the power 200 minus 1 is equal to 200. So guys, from here we can find out A. What is that? It is 450, 150. 150 divided by 2 to the power 200 minus 1. We have got first term as well as common ratio. Now to find this sum, from A1 to A1, A2 up to A200, what we can do? We can add these two, right? We can add these two. So when we add these two, this 201 is coming out to be extra, correct? This 201 is coming out to be extra and A is missing. The first term is missing. So can we say, let's call it Sn. Let's call it the final sum S. That sum S will be equal to 200 plus this 300. Okay, this is 300 and plus A and minus that extra term A201, which is A into R to the power 200. And guys, if you observe, this is nothing but 300 plus A is known, 150 divided by 2 power 200 minus 1. And what is this? 1 minus R to the power 200. It is 2 to the power 200. This will cancel out with a negative sign. So the value will be equal to 150. So your answer will be option D. Excellent question, guys. And again, in this problem also, it's only calculation, right? We are not getting too much into the concepts. It's just simple calculation, right? If you directly try to figure out the sum of GP, it might have taken slightly more time. But if you add it like this, the question will be simpler. So I hope you are able to understand these solutions, guys. Let's solve next one. Consider decreasing GP, so that G1 plus G2 plus G3. Now, this is also this might be a doubt for some students. Sir, what do we mean by decreasing GP, increasing GP? See, if terms are increasing, it's increasing GP, and for increasing GP, R is always greater than 1. Okay, consider that R is positive. Okay, obviously R cannot be negative, otherwise it will be alternate plus minus terms. We will not be able to say increasing or decreasing. R greater than 1, increasing GP. R less than 1, decreasing GP. That's all you have to count for. Decreasing, if it is say decreasing, that means R has to be less than 1. Now let's solve, guys. G1, G2, G3. So G1, G2, G3 will be A plus AR square divided by G1 square, G2 square, G3 square. So A square R square, A square R power 4 is equal to 13 by 91, which is 1 by 7. This we have. So with help of this equation, we need to find out A and R. We can do that, guys. What we can do here, take A common. So this will be 1 plus R square divided by 1A is cancelled out. In denominator, we have 1 plus R square plus R power 4, which is a factor form. We can write it as 1 minus R plus R square, 1 plus R plus R square. This is the formula, factor formula. Let's use it. So this will be 1 minus R plus R square into 1 plus R square is equal to 1 upon 7. So see, this will cancel out. Clear that 1 plus R square is getting cancelled out. So we have this relation that A into 1 minus R plus R square is 7, right? We got this one, that A into 1 minus R plus R square is equal to 7. And guys, we had one more, that G1, G2, G3 is 13. So what is it? A into 1 plus R square is equal to 13. So let's say this is equation number 2 and this is equation number 1. Again we can divide. So if we divide 2 and 1, right, here I am trying to solve. If we divide 2 and 1, divide 2 by 1. So 1 plus R square divided by 1 minus R plus R square is equal to, that will be 13 by 7. Cross multiply it. 7 plus 7R plus 7R square is 13 minus 13R plus 13r square. Okay, let's simplify it further. I hope the calculation is correct. Right. So 6r square, and this is 20r plus 6. Again, we can take 2 common. 3r square minus 10r plus 3 0. Now, can we factorize, guys? Definitely we can factorize. This is 3r minus 1 into r minus 3 0. So, r is either 1 by 3 or r is 3. Now, that's it. We have got two values of r, but still the final value of r will be dependent on this fact. Decreasing GP they want. So, if it is a decreasing GP, the common ratio r will be less than 1. So, what is the value of r, guys? R will be equal to 1 by 3. This is the correct one because it's a decreasing GP. It's a decreasing GP, so R will be less than 1. And once we get R, we can find out A also, and then you can check from these options. Okay, so I hope you can complete the remaining part of the problem. Let's move to the next section. Next problem. ABC are in AP, are not in AP. Then okay, ABC are not in AP. Then what we have to do? So nothing but we can see, if we add these two, we can take them in pair, and then we can take these two together. 1 upon C. Now, if you ask, sir, why did you take these two in pair? Because see, A plus C minus 2B, A plus C minus 2B. What is that? This has something to do with the info given that A, B, C are not in AP. That is why I took them together. Let's solve, see what happens. So the numerator will be A plus C minus 2B for both, divide by A times C minus 2B plus A plus C minus 2B, divide by C times A minus 2B. And this is 0, guys, right? This is 0. So if it is 0, next what you can do? A plus C minus 2B, A plus C minus 2B, you can throw it in the 0 side. You will have 1 upon AC minus 2AB plus 1 upon AC minus 2BC equal to 0. This is what we will have here, guys. So can we say that 2BC minus AC will be equal to AC minus 2AB. So we get 2BC plus 2AB is equal to 2AC. So guys, if you divide by ABC, we get 1 upon A plus 1 upon C is equal to 1 upon B, which we can also write it as twice of 2 by B. We can write twice of 2 by B. This thing. That means 1 by A, 2 by B, 1 by C will be in HP. So this will be AP. So this is the correct answer. Okay. This is the AP thing. Right. 1 by A, 2 by B, 1 upon 2B, 1 upon C. This is in AP. So the reciprocal A, 2B, C will be in HP. A, 2B, C. Not this one. The last one is correct. A, 2B, C are in HP. Right? I hope you have understood this sum, guys. And the hint to solve was the info that A, B, C are not in AP. That A plus C minus 2B, we can take common and we can throw it into 0. Clear? Let's solve the next one. Consider an arithmetic series and a geometric series having 4 initial terms from this set. Okay. So what will be the AP, guys? It will be 11, 16, 21, 26. And what will be GP? GP will be 2, 4, 8, 16. This is the GP. If the last terms of these series are the maximum possible 4-digit numbers, then the number of common terms in these two series. Okay, they are asking for number of common terms. So, what is general term here? Like if you observe, what is general term for this AP? It is right 11. This is 16 minus 11, 5. So this is like 5 D plus 6, right? Something 5m, 5n. Okay. Let's find out the general term, and there you will observe it is 5n plus 6. You put n equal to 1, 11, put 2, 16. And for this is 2 power n. This is 2 power n. 2 power 1, 2 power 2, 2 power 3, 2 power 4, right? Oh, okay, wait. 4 is 2 is not there, it is 4. 4, 8, 16. Right, 4, 8, 16, 32. Right, so this is 2 to the power n plus 1. 2 to the power n plus 1. Now we have to find out common term. So can I say that 5n, okay? So we have 2 to the power, let's say the way write this in some other variable. 2 to the power m should be equal to 5n plus 6. So 2 to the power m minus 6 should be multiple of 5, right? Now, which power of m can be multiple of 5? Can be multiple of 5 if that unit place is 6. So the first number, right? This is the important point. This has to be multiple of 5. Okay. So the difference, you see, the difference has, see, we cannot subtract such that the unit place is 5, right? But we can subtract in a way that the difference becomes 0 for the unit place, and then it will be divisible by 5. So we have to put those numbers due to which the difference becomes, the unit place difference becomes 0. So m should be 4, like 2 power 4, 16. So m equal to 4 is one option. Now next will be m equal to 8, then 12, then 16, and so on. But we cannot go beyond this 16 because 2 power 16 is not a 4-digit number. The last you can put is 12. So these are the 3 m values for which we can have a common term. We can have a common term only for this. So there will be how many? So number of common terms will be equal to, this will be equal to 3. Right? And this is the type of question we see in JEE Advanced, not in mains. It was simple. It was a simple, clear observation that was supposed to be that we were supposed to do here. But like this is, I'll categorize as slightly difficult because this is not what we expect from JEE mains. And that is what you see. This question is from 21. Right? So from 21, there have been some problems, not just in sequence, many other chapters which have like reached a different level. But I hope this explanation is clear to you. Let's move to the next one. Okay. Talking about means now. What is arithmetic mean? It is simply mathematical average of the given numbers. If you have numbers a1, a2, a3, a4, an for 2 numbers, okay? For 2 numbers. If 3 terms are in AP, the middle term is called arithmetic mean. So like if you say that if ABC is AP, then this B is called arithmetic mean A, which is equal to A plus C by 2. So if you have 2 numbers A comma B, its arithmetic mean will be A plus B by 2. Okay. If you have 2 numbers for A and B, for A and B, arithmetic mean A will be equal to A plus B by 2. Okay. And if you have n numbers, for set of n numbers, it is simply mathematical average. A equal to A1 plus A2 up to n divided by n. Right? Then, how to insert n arithmetic mean between 2 numbers? This question, you might see this in exams. This is a pretty easy one. We are going to use the definition of means. AP here. What is an AP? What is an AP? Or what is a mean? Not AP, guys. What is mean? If we insert, if we have, like, if you say, see, if you say that A comma B are in AP, then this A is supposed to be, this A is called arithmetic mean, right? So likewise, if I write 2 numbers A and B, and in between I insert means A1, A2, A3, AN, then B. Then this entire sequence will form an AP, right? This entire sequence of n plus 2 terms. How n plus 2 terms? Because you are inserting n means and A and B included, total n plus 2 terms, right? And this entire sequence will be AP, like you can see, no? 2, 4, 6, 8, 10, 12, like this. Suppose this is the example. So 4 is the arithmetic mean for 2 and 6. 6 is arithmetic mean for 4 and 8. 8 is arithmetic mean for 6 and 10. So what is it? It's like inserting 3 arithmetic means between 2 and 10. 2, 4, 6, 8, 10. What did that form? A complete AP sequence. So here we have n arithmetic means. So this entire sequence will be AP. First term is known, only common difference is remaining. So guys, can I say here that the common difference here, that the common difference of this, common difference for this AP, okay, this common difference here, common difference D is equal to, how to find out? Let's write the Tn plus 2 here. Guys, what is Tn plus 2? What is n plus 2th term for this series? It is B. B, which is equal to first term plus n plus 2 minus 1, n plus 1 into D. So that common difference D becomes B minus A divided by n plus 1. That's it. You need to remember only the common difference. Now you can write all the means. What will be A1? A1 will be A plus D. What will be second mean? A plus 2D. So what will be in general Rth mean? A plus R into D. That is what you need to remember. D is B minus A divided by n plus 1. What is that n? N is the number of arithmetic means that you are going to insert in between the numbers A and B. Okay. So there is one property related to it. The sum of n arithmetic means is equal to the n times single arithmetic mean. Right. Now, how is this true? See guys. So we had A1, A2, A3, AN, D, right? So what is sum of arithmetic means? A1 plus A2 plus A3 up to AN. If we have to find out this sum, this will be n by 2, the first term plus the last term. Now we know this is B, right? So this is B. Now we know the common difference here. What is it? D. The common difference is D, guys. So I can write n by 2 into A1 will be, what will be A1? A plus D. And this AN will be, what is AN? B minus D. So this DD cancels out and you have n by 2 into A plus B. That is what we had to prove, that sum of n arithmetic means is equal to n times the single arithmetic mean inserted between A and B. Sum of n means inserted between A and B is equal to n times single arithmetic mean inserted between A and B. Clear? I hope this is clear now, guys. Okay, remember this funda. Talking about geometric mean, you know, this is the root for ABC. If three terms are given in GP, then the middle term is known as geometric mean, right? So that B is equal to root AC here. So for two numbers A and B, geometric mean is given by square root of AB. This G will be root of AB. Okay, and if we have n numbers, obviously there will be some sign constraint that the product should be positive. Like if you have A1, A2, A3, AN, the geometric mean will be equal to A1, A2, AN to the power 1 upon n. Right, for two numbers A and B, it is AB to the power 1 by 2. For three numbers ABC, it is ABC to the power 1 by 3. For four numbers ABCD, it is ABCD to the power 1 upon 4. So for n numbers, given that the product is defined in positive. Okay, the same funda we can do. We can insert n geometric means, and the same funda applies here, that the entire sequence will be GP. Previously it was AP, this time GP. Why? You can see numbers like 2, 4, 8, 16, 32, 64 and so on. So for 2 and 8, 4 is geometric mean. For 4 and 16, you see 8 becomes geometric mean. For 8 and 32, this is geometric mean. For 16, 64, this is geometric mean. So it's like between 2 and 64, 4 geometric means have been inserted. So similarly, between A, if we want to insert G1, G2, G3, G4, G and B. If you want to insert n geometric means, okay, if you want to insert n geometric means, what you have to do, guys, what you have to do if you want to insert n geometric means, simply you need to find the common ratio. We need to find out the common ratio, because first term is known. So once we have the first term common ratio also known, we can write the entire series. So how to find out that R? How to find out that R, guys? A, G1, G2, G. How to find out that R? So this Tn plus 2 is B, which is nothing but A into R to the power n plus 2 minus 1. So guys, that's all. A into R to the power n plus 1 is B. So R will be B by A to the power 1 upon n plus 1. That's it. We got the value of R. Now you can write any geometric mean of this series. What you can write? G1. It will be A into R. G2. It will be AR square. So if you want to find out G, capital N, it will be A into R to the power n. Okay. And we have one property here, that the product of n geometric means G1, G2, G3, Gn is equal to nth power of the single geometric mean. Single geometric mean is AB to the power 1 by 2 and nth power of it. And I leave it up to you. You can prove it on your own. Just like the previously we did for AP sequence, you can prove it for GP sequence also. Memorize the result. That's all. Memorize the result, because this has been used, guys. This has been used in exams. So I'll recommend, do remember it. Okay. Moving on. Harmonic mean, just remember that. Harmonic mean for n numbers. Like if you have A1, A2, A3 up to AN. So harmonic mean will be equal to n divided by the sum of reciprocals. 1 by AN. Just remember it. You are not going to have many problems from harmonic mean, but in the A-G-H relation, there we can have a simple use of it. Okay? Fine. So relation between means. Here comes one of the most important points. We have two types of relation, the equality and inequality relation both. Talking about equality relation, G square will be equal to AH for two numbers. Right? How? Like for A and B, if we define arithmetic mean, it is A plus B by 2. If you define geometric mean, it is square root of AB. And for A and B, if you define harmonic mean, that is 2AB upon A plus B. Correct? So you can clearly see G square will be AB, A into H is also AB. So G square is equal to H. That is the equality relation. Equality relation if the numbers are in, if we are given with two numbers. And the most important result related to mean. Why? Because we have several questions in exam from this section. Okay. So the first and most important about this inequality is remembering this. Right? Positive. Right? If we are dealing with positive numbers, then only we are allowed to use all these. So if we have n positive real numbers, and this is how we define arithmetic mean, geometric mean, harmonic mean, then this is a relation. AM is greater than equal to GM, greater than equal to HM, and if we are using equality, then all the numbers will be equal. A greatest, then G, then H. They can be equal also if the quantities you are using are having equal value. I'll prove it for two values A and B. See, it's very simple to prove for A and B. Like for A and B, if I find out what is A minus G, it will be A plus B by 2 minus root AB. So I can write it root A plus root B square minus 2 root AB divided by 2, whole divided by 2. What is that? Root A minus root B whole square divided by 2. So this A minus G is something perfect square upon 2. Perfect square, that means always positive. A minus G is equal to perfect square by 2. Perfect square is always positive. So A minus G is greater than equal to 0, and that gives you A greater than G. You can see here, if you want A equal to G, A and B will be equal. Now the better proof is done using log graph, that we consider a log curve. We take points x1, x2, xn, and then we tell that the centroid is inside. That is the actual proof. But for understanding thing, this is also helpful. Okay, what you have to remember? First of all, the result for AM, the result for GM, result for HM, and this is a relation, and they are all, if all elements are equal, means will be also equal. Okay, so let's solve few problems, guys. Let's solve few questions. The first one here, AM of two numbers exceeds the GM by 2. Okay, exceeds the GM by 2, and the GM exceeds the HM. GM exceeds the HM by 8 by 5. Find the numbers. Suppose the numbers are A and B. Numbers are A and B. So what is G here, guys? G, I can replace here. Here we have G square equal to A into H, right? G square equal to A into H. What is A? G plus 2. What is H? G minus 8 by 5. So G square is equal to G square minus 8 by 5G plus 2G minus 16 by 5. So G squares cancel out. So 5 to 10, 10 minus 2, 2G by 5 is equal to 16 by 5. Right? 5 to 10, 10 minus 8, 2, 2G by 5. G is equal to 8. Geometric mean is 8. What is harmonic mean? It is 10. So root AB is 8, and A plus B is A plus B by 2 is 10. So A plus B is 20. So what are those numbers, guys? G is 8, right? So root AB is 8. So A into B is 64. So what can be those numbers? 16 and 4, best 16 and 4, 16 into 4, 64, 16 plus 24. So the numbers are 16 and 4. Quite simple. Using the result G square equal to H, we got the numbers. Okay. Now let's solve some PYQs. Okay guys, so let's solve this problem. G is the geometric mean of two positive numbers A and B, and M is the arithmetic mean. Okay. And M is arithmetic mean of A 1 by N, M 1 by B. So what is M? What will be M? M is basically, what is it? You can see this is 1 by A plus 1 by B by 2. This is M, right? And G is geometric mean of two positive numbers A and B. And G is root AB. This is given. M is the arithmetic mean. Okay. 1 by M is to G is 4 by 5. Right? What will be 1 by M? You can see this is equal to M is equal to, this is A plus B divided by 2AB. Right? M is equal to, this is 2AB, A plus B. So 1 by M will be 2AB divided by A plus B. As given that 1 by M upon G. So 2ab upon a plus b, then root ab. This is equal to 4 upon 5. This is given, right? 1 by m upon g is 4:5. So let's simplify it. Now we can cancel out. So 2 root ab divided by a plus b. This is equal to 4 upon 5. And what do we want? A is to b. We have to find out a is to b. So we have two options. Either we can go for componendo dividendo, or what we can do, we can square both the sides and simplify for a and b, a by b. So I think squaring will be better. So square both the sides. So 25 into ab, this will be equal to 4a square, 4b square, and this is 2ab, 8ab. So we get a quadratic. 4a square plus 4b square, and this will be 825 minus 17, a into b equal to 0. Okay, so I hope all the calculation steps are correct. 2ab upon a plus b, this will be root ab, 2 will cancel out, fine, right? 5 square 25ab, and this is 2 square 4 into 2, 8ab, right? So after this step we can divide by b square. We can divide it by b square, guys. So this will be 4a square by b square minus 17 a upon b and plus 4 equal to 0. So this is 4 into 4, 16. So I can write it here, 4a square by b square minus 16a by b minus a by b plus 4 equal to 0. If I take 4a by b common, this will be a upon b minus 4, and here I'll take minus 1 common, it will be a by b minus 4 equal to 0. Correct? 4a square b square minus 16ab, this is minus a by b and minus plus 4. So from here now we can have like a by b is either 4 or a by b is equal to 1 upon 4. So answer is 4 or 1 upon 4. What the ratio will be? 1:4. This b will be the correct answer, right? And we have the ratio is positive, so there is nothing else to check. The answer is 1:4, and this was asked in 2014. Right? The question has the question is very old, but you see this is how they ask from means also. Okay, let's solve next problem, guys. Okay, so small m, guys, what is given here? Small m is the arithmetic mean of two distinct real numbers L and N. Small m. There will be L plus N divided by 2. And what is given? G1, G2, G3 are the geometric means between L and N. Now this is something different. G1, G2, G3 are geometric means between L and N. Then they ask you what is G1 power 4, 2G2 power 4, G3 power 4. Okay, this is what they are asking. Now, see, here we have two methods. Either you can go for the property, like how to find out the geometric mean between two numbers L and N. We can find out G1, G2, G3 in terms of L and N. You can see your answers are also in terms of L, M, N. So that is not a problem. Okay, if you remember that concept, we can very easily go for that. Or we have one more way. What we can do, we can write everything in terms of GP. Right? Like this G1 power 4, this G1 power 4. See, this G1 power 4, what I can write? G1 square. What will be G1 square? It will be L into G2. What will be G3 square? G3 square will be equal to G2 multiplied by N. Why? Because this entire sequence will be GP. If you insert geometric means between two numbers, then the entire sequence will be a GP. So as per that, I have written these results. So in the problem, I am going to replace G1 and G3 with these values. So what will be G1 power 4? G1 power 4 will be L square, G2 square, right? L square, G2 square, plus this is twice of G2 to the power 4, and plus G3 power 4 will be G2 square, G2 square into n square. Now, what is the benefit of writing everything in terms of G2? See, this G2 here is the mid value. So can I say that L, G2 and N, because they are at equal distance from G2, so L, G2, N will be a GP. This will be also GP. So from here we can write that G2 square will be equal to L into N. This is a GP series and we have done this property. If they are at equal distance, then that says those three numbers will be also in GP. So L, G2, N are in GP. We can write G2 square as L into N. That's it, guys. Replace everything in terms of L and N. So this will be L square. G2 square will be L into N plus G2 power 4. G2 power 4 will be twice of L square, N square plus G2 square, N square. What is G2 square? L into N. So it will be L into N cube. Right? So what can we take out common from here? We have L cube N, like L square. So let's take L into N common. So if you take L into N common, this will be L square plus 2 Ln plus N square. And what is this? This is L into N. This is L plus N whole square. And what is L plus N? It is this L plus N here is 2m. So replace it here. So Ln into 2m whole square, and this gives you 4m square L into N. So this is your answer, 4m square L into N. B is the correct answer. The question was calculative, right? You can go for the other logic also of finding the common ratio R. If you insert few numbers in between A and B, you can calculate common ratio R and you can find G1, G2, G3. But I think this one was the better, this is the better method to solve this problem. Here, by simple use of GP, we solved. We didn't even use any like mean property here. We could have used that, but obviously this is easier. Okay guys, so I hope you have understood this. Let's solve next one. Moving on, guys. Now the best question, considering mean inequality in JEE main, right? See what is happening here. X, Y, Z be positive real numbers such that x plus y plus z is 12 and x cube y power 4 z power 5 is given this thing. Then x cube plus y cube plus z cube is equal to. Okay. Now we have x cube y power 4 z power 5. Product is given, sum is given. So since we are given x cube y power 4 z power 5 and everything is given positive, so what I'm going to do, I'm going to create those numbers. We have only x, but I need to get x cube in the product. So I'm going to rewrite this relation. I'm going to rewrite this relation, guys, like this: x by 3 plus x by 3 plus x by 3 plus y by 4, y by 4, y by 4, y by 4. Okay, then z will be written 5 times plus z by 5, z by 5, z by 5, z by 5, z by 5. This is how I'm going to write it. Why? So basically I'm going to use AMGM on these numbers. This is what I'm going to do. What I'm going to do, like on all these numbers, AMGM, I want to calculate AMGM for this set. Okay, I'm going to calculate AMGM for this set. Right, just put a comma in between. These are the numbers which I'm going to consider for AMGM. And what is the hint? Right? What is the hint, guys? What is the hint that we have to? What is the hint that we have to find out? What is the hint that we have to find out right numbers in this way? That product. So for this number, if I find out what is arithmetic mean. So if you add everything, it will be total. There are 3, 4, 7, 5, 12. So arithmetic mean will be like you add everything, x by 3 up to z by 5, divide by 12. So the overall sum will be still x plus y plus z, divide by 12, you get it equal to 1. You will get it equal to 1. Now find out geometric mean for this set. This is arithmetic mean for this set. Now find out geometric mean for this set. So geometric mean will be x cube y power 4 z power 5 divided by 3 cube 4 power 4 5 power 5 whole to the power 1 by 12. This is geometric mean. Now we are given with few values. Let's substitute it here. What values we are given with? We have values of x cube y power 4 z power 5. Replace it here. So this is 600 cube. This is 600 cube into 0.1 and then divide by 3 cube 4 power 4 into 5 power 5 whole to the power 1 by 12. And this is the determining step here. What happens that when you calculate this bracket, you get it equal to 1. This all things will cancel out and this thing is going to be equal to 1. So this comes out as 1. And the moment geometric mean also comes out to be 1, you see you have a deal now, because arithmetic mean and geometric mean have come equal. A and G have come equal. So if arithmetic mean and geometric mean are equal, then what is going to happen? All the elements will be equal. So we have x by 3 will be equal to y by 4 will be equal to z by 5. These three will become equal. And since sum is 12, so let's say x is 3k, y is 4k, z equal to 5k, then you will see, depending on this relation, right? Depending on this relation, you will replace, let's put it equal to some k. So x equal to 3k, y equal to 4k, z equal to 5k to become 12k, k is equal to 1. So that means x is 3, right? So from here you will get x is 3, y is 4 and z is 5. This is what you will get, right? This is what you will get. X is 3, y is 4, z is 5. So now you can calculate. We want x cube, y cube, z cube. So 3 cube is 27, 4 cube 64, 5 cube 125. So how much is that? 64, 27 will be 91, right? 91 plus 125. So this will be 391 plus 125, 216. This is your answer. This is your answer. Clear? Excellent question. Like one of the best questions by far. The questions in the quality talk question that we have done, and also from this topic AMGM. Okay. Like in general, we don't see this level problem in JEE mains, but still, if you have the clear idea of inequality, you are going to solve it. Okay. Let's solve next question, guys. So x, y, z be the positive real numbers, m, n are positive integers. The maximum value of the expression. Okay, everything is given positive. So they have already set up. They have already set the background for AMGM. You see this expression we want. What do we want? Maximum, right? So let's say this is expression E. So let's divide x power m, y power n in the denominator. So this will be 1 upon x power m divided by 1 upon x power m, right? Because you'll divide. And this will become y power n plus 1 upon y power n. This is what it will become after dividing. Right? This thing divided by x power m, that thing divided by y power n. Now we can clearly use the AMGM on this. These two are independent of each other. So can I say like x power m plus 1 by x power m divided by 2 is greater than equal to x power m into 1 upon x power m. What is this? So x power m divided by 1 power x power m is always greater than 2. Similarly, you will have y to the power n plus 1 upon y to the power n greater than equal to 2. So we got minimum of these two, right? So if you want to maximize E, right? Guys, if you want to maximize E, so E maximum will be 1 upon when you divide by minimum. And you can see here that for these two expressions, the minimum is 2 each. What will be maximum of E? 2 into 2, 1 upon 4. 1 upon 4 is the maximum value of E. Your answer will be B option. Clear? I hope the logic is clear, guys. Okay, let's solve next one. Okay, so in this question, what is given? X is positive, the greatest value of the expression. Now, this question is exactly similar. Greatest value they're asking for this. So you divide x power 100 into denominator. It's given that they all are positive. right? It's already given that everything is positive. So you divide, same process, divide it. When you divide, this expression e will become 1 upon, what is it? 1 by x power 100, right? Divide with this x upon 100, it will be 1 by x power 99, 1 by x power 98. Somewhere here you will have x power 100 also. Like somewhere here we have x power 100 also. So when you divide, it will become 1. Then after that, this will be x square, x cube, x power 100. This is how this is going to look like. Now, here how many terms do we have? Up to x, okay, up to 1 by x. Now here we have 100 terms. Here we have 100 terms, and then this one. So total 201 terms. Total 201 terms. So on these 201 terms, I'm going to use AMGM. Okay. On these 201 terms, I'm going to use AMGM. So guys, what will be arithmetic mean? This whole sum. Let's say this is some expression f. Right? I'm calling this expression as something f. So f divide by, okay, I'm using this a greater than equal to g. So this f divided by 201 is greater than the product of all. What will be the product? You see, for every 1 upon x, we have that x also. Like this will cancel out. X power 99, somewhere here x power 99 will be there. All these things will cancel out. It will make it 1. 201. So this expression f is always greater than 201. So we got minimum of f. We got minimum of f as 201. So you want to maximize e. You want to find out greatest value of e. So same process, you will put the minimum value. So from here we can say that e max is equal to 1 upon 201. This will be the answer. Clear? So in the same process, you just divide it, and once you see fx upon 1 upon fx expression, half of the job is done. Fx upon fx being positive, minimum will be 2. Provided domain is like, it's in the range. Okay? Let's solve next. A plus b plus c is 3. A positive, b positive, c positive, greatest value of a square. So we have seen like how to use this. Whenever sum is given, right? Whenever sum is given and product is asked for minimum, okay, we can use AMGM, and also we have to write that sum in a way such that we can frame this as the product. We have to write that sum in a way such that we can exactly get this. So we want a cube, but here we have only one a. We want a cube, but we have only one a. So we can break that a into 3 different a's, and we know how to do that. We'll rewrite this relation as a by 3, a by 3, a by 3, a by 2, a by 2. So we want a square, right? A by 2, a by 2. And then b cube is there. So b by 3, b by 3, b by 3. Then c square is there. So c by 2, c by 2. This is what we are going to consider for AMGM. Okay. So use on these 3 to 5 to 7. On these 7 numbers, use AMGM. A greater than g. What will be sum? It will be a plus b plus c. Because if you add them overall, it will be same. How many terms? 7. Geometric mean. A square, b cube, c square, right? Divide by 2 square, 3 cube, 2 square, whole to the power 1 by 7. Right? We use AM greater than GM. So you can clearly see a plus b plus c is given 3. So this is 3 by 7. And remove that 1 by 7 from this side. So it will be 3 by 7 to the power 7 multiplied by 2 square, 2 power 4 into 3 cube is greater than a square, b cube, c square. What is the maximum of it? Right, the greatest value will be equal to, this is 3 power 10 into 2 power 4 divided by 7 power 7. 3 power 10, 2 power 4, 2 power 4, 7 power 7. A is the right answer. Clear? One of the a standard sum in AMGM. Sum is given, product is asked. Sometimes product will be given, sum will be asked. So that is how we manipulate it. Okay. I hope you got this. Let's solve next one. Minimum value of fx where a is positive. Obviously, this is like exponential. Okay, see, this is 2021 question. The logic is very simple. You write it as fx 1 upon fx. This is a to the power x plus a upon a to the power a power x. And since everything is positive, we can go for AMGM. This will be 8 power a power x plus a upon a power x. Divide by 2 will be greater than equal to. When you multiply these two, this will cancel out. It will be only a. So this a power x plus a upon a power x will be greater than 2 root a. So this is the answer. Right? Options are missing here. The answer is 2 root a. The answer is 2 root a. Quite simple. Quite simple. Just use AMGM and see. This is not difficult to identify that we have to go for AMGM. How? Fx 1 upon fx. If 1 upon fx is with some positive constant, no problem. But if we have fx and 1 upon fx, that's it. Jackpot. Go for AMGM. Everything is positive provided. You okay? Next one is from also 2021. Arithmetic mean and geometric mean of pth and qth terms of the sequence satisfy the equation this. Okay. So this equation I think we can simplify. 4x square 9x minus 5. This is 4x square minus 4x minus 5x plus 5 equal to 0. So this is 4x x minus 1 minus 5x minus 1. So we got two roots, 1 by 4, 1, sorry. We got two values here. We got two values. What is it? X equal to 1, comma 5 by 4. And these are what? Arithmetic mean, geometric mean of to satisfy this. Which one is arithmetic mean and geometric mean? Obviously, arithmetic mean will be greater. So arithmetic mean is 5 by 4 and geometric mean is equal to 1. Right? We got arithmetic mean and geometric mean. Now what is next? Pth and qth term of the sequence. Now what is TP? What is TP, guys? What is pth term of the sequence? This is GP minus 16, 8, minus 4. So GP with common ratio minus half. So what will be pth term, guys? What will be pth term? Pth term will be equal to what will be TP? TP. Pth term will be equal to A into R to the power P minus 1. Fine. And what is qth term? Qth term will be A into R to the power Q minus 1. Right? We have written TP and TQ. Now what is given? Geometric mean is 1. So if geometric mean is 1, so root TP into TQ is 1. So product TP into TQ has to be definitely 1. Now multiply these two. So this is 16, 16, 16 square. Right? 16 square into, if you are multiplying these two, so minus 1 to 1 by 2 to the power P plus Q minus 2 equal to 1. Now 16 square we can take it to RHS. So this will be minus 1 by 2 to the power P plus Q minus 2. Now 16 is 2 power 4. So this will be 2 power 8. 1 by 2 to the power 8. Now 1 by 2 power 8 or minus 1 by 2 power 8, there is no difference. So we can rewrite it. Minus 1 to the power P plus Q minus 2 equal to minus 1 to the power 8. So we have P plus Q minus 2 equal to 8, and that is going to give you P plus Q equal to 10. So that is the answer. The P plus Q is equal to 10. This is the answer. See, again it was calculative. They have tried their maximum. They have tried their maximum to complicate it. Because in this question, if you start like solving TP and TQ, it will be disaster, guys. If you solve for TP and TQ separately, obviously not, because we got geometric mean value, that is 1. It was easier to calculate with the geometric mean. Okay, so just keep your brain 100% functioning while thinking of the approach. Otherwise, if you get started with the wrong approach, then your life will be very difficult. Next question. Not question. So there we'll start a new topic now, which is AGP series. Now you have definitely like heard in you have heard, you have seen, might have done also. So arithmetic mean AGP is nothing but it is the corresponding product of AP sequence and GP sequence. You just multiply the corresponding terms that will form a AGP series. Okay. See. Series is term of which is found by multiplying the corresponding terms of an AP and GP. Right? I'll show one of the series. Let's say we have 1 x, x square, x cube, x power 4. What is the GP? Then write any random AP. Write any random AP. Let's say 5, 7, 9, 11. So this is AP. Now when you multiply corresponding terms, okay? When you multiply corresponding terms, first term of AP, first term of GP, like that. So you receive, you get this type of series 5, 7x, 9x square, 11x cube. So this series is known as AGP. This sequence is known as AGP. Is that clear? You can always segregate AP and GP part in any AGP given series. Okay. Now there is only one type of question framed, which is find sum of the AGP series, and there is only one way. This is the funda, guys. Funda of AGP series. How to solve any AGP series? This is the funda. What is it? Just look at it. To find Sn or S infinity, you might have a infinite AGP or you might have a finite AGP. For both, okay, multiply is written very nice. Multiply Sn or S infinity by the common ratio and subtract both series. That's all. That is all required to solve any AGP series, no matter how tough it is. If first subtraction is not giving you result, subtract again. You'll get it. Right? If there are chances that the first subtraction won't give you the result, doesn't matter. You subtract it again, but that is the only funda. Multiply by common ratio and subtract. Okay. So let's solve few. Now this is up for. This was a long back, but this is just to show how things work. Okay. So this is the AGP series. How to identify? Guys, how to identify? You can see AP there. 2, 6, 10, 10, 14. So let's solve this part. Okay. Let's solve this part. Let's call it S infinity. Then we'll find out what is 1 plus S infinity. So S infinite you have is 2 by 3, 6 by 3 square, 10 by 3 cube, 14 by 3 power 4, up to infinity. Infinite AGPs are far more easier to solve. Okay, so this is S infinity. Now what is the funda? To solve, we multiply by common ratio. Now for this GP, what is common ratio? 3 square, 1 by 3. Multiply this series by 1 by 3 and subtract. So 2 by 3 square. Then this is 6 by 3 cube, 10 by 3 power 4, 14 by 3 power 5, up to infinity. Now when you subtract these two, when you are subtracting these two, okay, when you are subtracting these two series, this will be S infinity, this will be 2 by 3, 1 minus 1 by 3. Now this is how we'll subtract, because the same denominator will be subtracted. 3 square, 3 cube, same denominator will be subtracted. So the first term will be written as it is, 2 by 3. 2 by 3 plus 6 minus 2, 4 by 3 square. Okay, 10 minus 6, 4 by 3 cube. 14 minus 10, 4 divided by 3 power 4, and this will keep on going till infinity. The series will continue till infinity. Right? So this is equal to 2 by 3 plus. This is 2 by 3 times S infinity is equal to 2 by 3 plus. Now here I can take 4 by 3 square common. If I take 4 by 3 square common, what do we have? 1 plus 1 by 3 plus 1 by 3 square up to infinity. Solve this infinity series. This is 2 by 3 plus 4 by 3 square into A upon 1 minus R, which is 2 by 3. Right? What this is the infinite GP? A first term is 1. Common ratio is 1 by 3. So 1 minus R will be 2 by 3. So 1 will cancel out. This is 2, 4 by 3. Okay, so from here we get S infinity as 2. So if S infinity is 2, our answer will be 1 plus S infinity. So it is 3. So this is how AGP will work. You just multiply by common, that's it, nothing else. You just multiply by common ratio, subtract the series, you are always going to get the answer. There is no second way. And you should not have any second thought also while applying the logic. Okay, so let's solve few more, guys. The sum equal to, now this is up to how many terms? Here we have k equal to 1 to 20. How many terms we have? We have 20 terms. This is given in the form of sigma. Let's write it. Let's write the sum here. What will be the sum? So the sum of 20 terms is equal to, put k equal to 1. So 1 into 1 by 2, put k equal to 2. 2 into 1 by 2 square, put k equal to 3. So 3 into 1 upon 2 cube. Put k equal to 4. 4 into 1 upon 2 power 4. And this will go for the 20th term. What is 20th term? 20 into 1 upon 2 power 20. Right? Open that sigma. We have here the AGP term. Now, in this series, same logic will multiply by the common ratio, which is 1 by 2. So 1 by 2 times S20 will be equal to, this will be 1 into 1 by 4, or let's write it 2 square, plus 2 into 1 by 2 cube, plus 3 into 1 by 2 power 4, 4 into 1 by 2 power 5, up to the last term will be 20 into 1 upon 2 power 21. Because we are multiplying 1 by 2, so we'll have 1 power of 2 increased in every denominator. What is next? Subtract. Subtract both sequence. When you are subtracting, this will be 1 minus 1 by 2. So S20 divided by 2 equal to, this is how you subtract the common denominator. So 1 into 1 by 2, 1 by 2. This will be as it is. 2 minus 1, 1 by 2 square. Then subtract these two. This and this. 3 minus 2, 1. So 1 upon 2 cube. Then 4 minus 3, 1 upon 2 power 4. And this will continue till, the subtraction will continue till here, which will be 1 upon 2 power 20. But this will be as it is with a negative sign. 20 into 1 upon 2 power 21. Why is that as it is? Because it won't have anything to get subtracted with, right? The maximum power of 2 is 21. Here it is 2 to the power 20. So the subtraction is happening like in this way. So this will have no pair. It will be as it is. Now, you can clearly see we have a GP sequence here of 20 terms. We have a GP sequence of 20 terms simplified. So S20 by 2 is equal to, what is it? What is it? A into 1 minus R to the power n. So R to the power n, which is 2 power 20, divided by 1 minus R, right? And minus of 20 into 1 upon 2 power 21. So 1 minus half, this will cancel out. What is this equal to? 1 by 2 cancel out. Now multiply that 2 also. If you multiply that 2, so S20 will be equal to, this will multiply here, this will cancel out. So 2 minus 2 upon 2 power 20, okay? And minus, this will be 20 upon 20, okay? So if you subtract now, this is 2 minus 22 by 2 to the power 20. So take 1 out and this becomes 2 minus 11 divided by 2 power 19. This is your answer, guys. 2 minus 11 divided by 2 power 19. B is the correct answer. Okay. Method is exactly the same in every AGP question. Same approach you are going to see. Like this is like very, you will consider this to be a bonus thing. You should be considering this to be a bonus thing in exam. Because guys, there is no alternate approach. Just subtract by multiplying the common ratio. You are definitely going to get the answer. Okay. Let's see if we have any other PYQs. So yeah, we have from Feb 2021. And I think this is almost similar to what we have done. And the good thing is that they're asking for infinite. When you are solving infinite series, it becomes 50% easier, right? Because there is nothing to write in the end. So guys, this is S infinity is equal to 1 plus 2 by 3 plus 7 by 3 square plus 12 divided by 3 cube plus 17 divided by 3 power 4 up to infinity. So we'll multiply by 1 by 3. That is the common ratio. It is 1 by 3 plus 2 by 3 square plus 7 by 3 cube plus 12 divided by 3 power 4 plus 17 divided by 3 power 5, and this will go up to infinity. Let's subtract both series. So 1 minus 1 by 3. 2 by 3 into s infinity will be equal to. So 2 by 3, 1 by 3, 1 by 3. So 2 by 3 plus 1 by 3 will be 1 by 3. Right? This is how we'll subtract. Then 7 by 3 square, 2 by 3 square, 5 by 3 square. Then 12 by 3 cube, 7 by 3 cube, 5 by 3 cube, plus 17, 12, 5 by 3 power 4. No need to write further. Save your time. So this 2 by 3 into s infinity is equal to, now 1 plus 1 by 3, then we can take 5 common from here. This is 4 by 3. This is 4 by 3. Let's take 5 by 3 square common, and then we have an infinite GP 1 upon 3 plus 1 upon 3 square up to infinite. Simplify this infinite GP. So 2 by 3 times s infinity is equal to 4 by 3 plus, this is 5 by 3 square into a upon 1 minus r, that is 2 by 3. So this 3 will cancel out, and what is this going to be equal to? This is 5 by 6, right? So from here you can calculate that s infinity will be, multiply there. So this is 3 by 2. So this will be 2, right? Multiply 3 by 2. 2. So 3 will cancel out here. 2 will also cancel out, and this is 5. So this is going to be equal to 7, right? If you multiply 3 by 2 here, so 3 will cancel out, and that 2, okay, wait. This will be by 2, no? This is by 2. So into 3 by 2. So 5 by 4. So this will be 2 plus 5 by 4. So 4 to 8, 8, 5, 13. This will be 13 by 4, guys. The answer will be something 13 by 4. Okay. So I hope you got the logic. You got the logic, what steps we have to follow here. 5 by 3. Okay. Every time it is same. Multiply by common ratio and subtract. Moving on to the one of the few topics which has so much importance, not just for sequence. Like this sigma notation, it's just like it's everywhere. In any chapter, if you like go for sum, there you will see this sigma thing. Okay, so let's understand what is sigma notation. So sigma we use for continuous addition, consecutive addition. Okay, we define a general term. We have a variable on which sigma will be dependent. Right? When we write, let's say when we write this sigma of something f of r. By f of r, I mean some general term. Okay, f of r will be a general term. So we put that thing from 1 to n. This is the limit of that variable, and it will vary. It's totally up to you. If you are having n terms, 1 to n, n plus 2 terms, 1 to n plus 2. Then what we do? We start with the least value of r, which is this, and we substitute it here, and we do this till we reach from 1 to n consecutively. We are not supposed to skip any value. Start from that least value, go up to the maximum, and it should be consecutive. So f1, then after 1, it is f2, f3, and the other values. Okay, if you have something, let's say sigma r equal to 1 to n, if we have, or let's say r equal to 10 to n, and we have a tr here. So this will start from 10, t10, and it will continue, it will increase consecutively till you reach n. This is what sigma does. It just adds. It's a compressed format of writing a sum series. Okay, so just a compressed format. This is the thing, t10 to tn, this is how you write it. You can change lower limit, you can change upper limit. This is how sigma works. But it is only for addition purpose. Okay. Now there are some properties associated with sigma. Like there are some confusions which needs to be avoided. The first one, you can only split sigma if the general terms are in addition or subtraction. Like here, AR is one general term. Okay. AR is one general term, BR is other one. So you can see here we have split it with the sign plus minus, right? You can only split if you have addition subtraction. I'll mention some PAPs, right? Right, what are the some PAPs which students do? PAP means crime. That crime you have to ignore. Like some students, some LUL students, what they do this. Sir, sigma r power 4. So let's write it r square into r square, and let's write it like this, r square into r square. No, this is completely wrong. You cannot split sigma into product or division. Like if it is sigma fr divided by gr, this is not equal to sigma fr divided by sigma gr. No, no sir, no. This is not true. Sigma 1 upon fr is not equal to 1 upon sigma fr. No sir. This is not how sigma works. Okay? If you want to split sigma, it can be done only if the general terms are in addition or subtraction. That's all. That is all. Addition and subtraction. Next thing. See, this is the main variable for the sigma, right? R here, you can see it will be dependent on R. And if there is any constant, anything apart from that R, if something is not dependent on R, it becomes a constant for that sigma thing. Okay? And we can always take that sigma out. This is k times this. And if you are only adding constant, number of times into k. Okay? Remember it. Sigma constant. Sigma of any constant will be equal to number of terms multiplied by that constant. That's all. And what is constant for sigma, you will always know. Not only numbers are constant. No, not only numbers are constant. If you have something which is not dependent on the variables mentioned for sigma, it will be constant. Let's say suppose if I write this, that sigma r equal to 1 to 10, and here I have x plus y square. Now don't you see that there is nothing dependent on r, right? So this entire thing x plus y square is a constant for you. So it will be x plus y square multiplied by number of terms from 1 to 10, that 10 terms. Number of terms multiplied by constant. And how to judge number of terms? See, if you have to find out number of terms from r equal to a to r equal to b is b minus a plus 1, including a and b also. Okay, including a and b. This is the inclusive. The including a and b also. From a to b, like from 1 to 10, we have 10 minus 1 and plus 1, total 10 terms. So this is what you need to know about sigma. Now we have some standard results for sigma that we use everywhere. See, in general, what is happening? To solve any problem, we can find a general term, and then once we have got the general term, we can write that with sigma operator, and we can find out. Now, general term will be mostly function of r, and we have some formulas which we can directly use to find different questions which have some related to sigma, and that too the function is dependent on these, like either it is r square or r cube. So this is the formula. The first one, sigma r equal to 1 to n. Now this is sum of first n natural numbers. What is it? This is general term. If you put values like this, is nothing but 1 plus 2 plus 3 up to n. But mind it should start from 1. It has to start from 1. Only then this is only then you will be able to use the formula. Okay? R square. Sum of squares of n natural number. Like this will be, this is nothing but, this is 1 square, 2 square, 3 square. So if you are adding up to n square, this is the value. N into n plus 1 to n plus 1 by 6. Then for cube, this is the value. Okay? This is the value. And this is also equal to, for like coincidentally, this is also equal to n into n plus 1 by 2 whole square. Is that clear? So we have sum of n numbers, sum of squares of n natural number, and sum of cube. And mostly, in fact, 100% times, if you are dealing with sigma, tr, these are going to be in the functions of r square, r cube. If they are in numerator, like if you have the general term, this is what you are going to get it. Sigma r square. Wherever you have sigma r square, sigma r cube, the problem is over. The problem is over. Okay. There are a few more like r power 4. Now this is not necessary. You can skip r power 4. You will have only till r3, r power 3. Sigma r power 4 is not in our syllabus. If you are pro at rectification, you can remember it, but I don't recommend. Now this is also important. R equal to 1 to n square. Now see, 2r minus 1 is what? A general term of AP. So we are adding, this is sum of first and odd natural numbers. Right? 2r minus 1 is what? 2r minus 1 is what? This starts from 1. So if you add first n natural numbers, it will be n square. Like suppose if you add 1, 3, 5, 7, 9, 11. How many natural numbers? Odd. 1, 2, 3, 4, 5, 6. 6 odd numbers. 6 square. 36 will be answer. You can see 11, 9, 20, 27, 32, 35, 36. So if you are adding first n odd numbers, the sum will be n square. And 2r. If you are adding first n even number, it is n into n plus 1. Is that clear? So these are the all results which will be very handy because we are going to get general term in general terms in terms of only these. Okay, our ultimate aim will be only to find out general term, and that is where the most of the students struggle. And it is so easy. I don't know how you people are not comfortable with finding general term. General term is just a pattern. You try to identify the pattern. You write T1, you write T2, you write T3, you write T4. By T3 itself, you will be able to see what is the relation between that subscript and those numbers written after the equal to thing. Clear? I'll show you how to write general terms. Okay, here we have few more. See, if it is sigma r, what was sigma r? N into n plus 1 divided by 2. So if it is r into r plus 1, this will come out as n plus 1 n plus 2 by 3. n plus 1 n plus 2 by 3. Then if you have one more r plus 1 and r plus 2, then you see the result n plus 1 n plus 2, then one more divided by 4. This kind of pattern. Okay, you can remember it. If you have directly r plus 1 r plus 2, this is how you can write it. Now a plus rd into b power r, that is a AGP. We don't have a direct result for this AGP, right? We have, but the standard procedure we are aware of. If we have a AGP sequence, what we do? We have to solve. We have to multiply by the common ratio, subtract and solve. Okay. So these are the few important results which you have to memorize. Before we go for the question, I want to write one more, guys. One more, GHI. So the result number J. I'm going to write one more. It has been there 2-3 times, and it takes a lot of time to calculate. So let's make it a formula itself. So it is 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square plus, okay, 1, 2, 3, 4, 5 square up to. If this is up to n terms and this is equal to, okay, this is n terms. So this is equal to n into n plus 1 whole square by 2, where n is something even. This is more important here, guys, that this result is valid only for even number. If your series is like finishing at some end, like even term, 2 into 2 square, 2 into 4 square, this is how you give the result. And if n is odd, right, 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square, 5 square up to n terms. And suppose n is odd, right? The first one is for even. If n is odd, then n minus 1 will be even. Getting my point? If n is odd, so n minus 1 will be even. So this will be n minus 1 into n minus 1 plus 1 whole square by 2 and plus n square if n belongs to odd. If n belongs to odd. Right? Because see, we know how to solve for even terms. So, and every odd term, you can directly see it is 3 square, it is 5 square. So if n is odd, So we'll find sum up to the even term just before it. Then what is only left? That the last odd term, and it is always n square. So this is how you'll get the result. So these two have been there in exams. So I'll prefer memorizing it. It will save our time. Okay. So all these results, remember it. And the only one thing to solve any sequence, right? This is the only thing which we are going to do everywhere. To solve any sum, problem, right? Find general term. This will be our first thing. Find general term. Find general term TR, then sum of n terms. Sum of n terms is going to be equal to, Sn is going to be equal to sigma TR. That's all. Sigma TR, that's all. Sigma TR will be the final, and the sigma TR, that TR, if it is one of these, that's it, you'll get the answer. Okay, so let's start solving, guys. Let's start solving problems. First one from the long back 2013. Just to start with some easy sums, I've taken these. Sum of the series 2 square, then 2 into 4 square, then 3 into 6 square, and up to 10 terms. So see, this was 1 into 2 square, 2 into 4 square, 3 into 6 square. You can see it now. You can sense it now. What will be next? It will be 4 into 8 square. Getting my point? 1 into 2, 2 into 4, 3 into 6, 4 into 8. Now, what to be done? What do we have to do? We have to write general term. That's all. That is the only thing we have to do always. Write general term, because after that it's only use of formula. So I'm going to write it. If you are weak at writing general terms, just listen carefully. So if you are, let's say you are a very lull student, write all the terms and try to get the relation between subscript and the term. So T1 is 1 into 2 square. T2 is 2 into 4 square. Now this 4 square, I'm going to write it like this. 2 into 2 square. What is T3? T3 is 3 into 6 is 2 into 3 square. What is T4, guys? T4 is 4 into 2 into 4 square. I hope now you can relate. You can now relate what is the relation between that subscript and the term. Like if it is 4, you see, if it is 4, this is 4 and this is 4. If it is 3, this is 3, this is 3. This 2 is constant. 2, 2, 2, 2. Like this was 2 into 1 square. Like this 2 is constant. So this is 2, this is 2, this is 2. So can I write that TR is going to be R into 2 into R square? That's all. This is the general term. TR, if it is R, by 4, 4, 4, 3, 3, 3, 2, 2, 2, 1, 1, 1. So it is R, 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 R. And that 2 there is already present. That's it, khatam. We got TR. That's it. TR is equal to now 4R cube. Guys, we got TR is nothing but 2 square is 4, 4 into R cube. R square into 4R cube. And what we have to do, we have to find sum up to 10 terms. So what will be S10? It will be sigma TR, R from 1 to 10, which is equal to sigma R equal to 1 to 10. We can keep that constant outside, 4 into R cube. That is 4 into, what is R cube formula? We know it. N into n plus 1 by 2 whole square. That is why it is important. If you don't remember result, the last step, there is only one thing to do to get the final answer, and you will destroy everything. All these hard works, you will destroy it. Remember the formulas. So sigma R cube will be n into n plus 1. N into n plus 1 by 2 whole square. So this is 4 into 11 square into 5 square. That's it. And I don't know what is the answer. You can calculate and mark it. But I hope the idea is clear here. Okay, let's solve next one. Next question. This is easier, right? This is even easier. 1 square, 3 square, 5 square up to 25 square. You have continuous odd values 1, 3, 5, but with square. So either you can write general term, okay? Either you can write general term, or you can complete the series so that we can use sigma R square. Remember, sigma r square, r is continuous from 1 to n. There should not be a gap. That is the consecutive, consecutive, you have to put all the variable value, r from 1, 2, 3, 4 like. So there are two things. You write a general term and solve or. Okay. So I'll do both of these things here. Method 1. I'm going to add the remaining terms to complete the series. So this is 1 square, 2 square, 3 square up to 25 square. What I did, I added 2 square, 4 square up to 24 square. Subtract it also. 2 square, 4 square up to 24 square. So this we know how to solve. N is 25. So n into n plus 1 into n plus 2n plus 1 divide by 6 minus 2 square, 4 square up to 24 square. From here we can take 2 square common. So if you take 2 square common, this will be 1 square, 2 square, 3 square up to 12 square. So this is how much? We can simplify it. This is 2 into 3. This is 2 into 13. And this is 3 into 17. So this is 25 into 13 into 17 minus this 2 square into 4. And now this is sum of squares of 12 terms. So we know how to write sum of squares of 12 terms. What is it? N plus 1, 2n plus 1, which is 25, divided by 6. So we can cancel out. This is 6 into 2, 12. So guys, we can take 25 into 13 common. And what is left out? 17 minus 17 minus 8, 9. So this is your answer. 25 into 13 into 9. That is your answer. Okay, I don't know what is it. Just multiply it and you will have your answer. But I have the logic is clear. Okay, this is method 1. What we did to complete the series, we added remaining even terms and we solved it. Or method 2, we can directly write the general term by using general term. Because this is going to work everywhere. If you have any confusion, write a general term, use sigma, you will be able to solve. General term, what is it here? General term for this, like T1. T1 is 1. T2 is 3. T3 is 5 square. So can you relate it with the subscript? Like 2 is 3. Okay. So obviously these are odd values. So this is basically AP 1, 3, 5. Right. This is AP square. This is AP square. So TR will be this rth term of AP. Rth term of AP, whose first term is 1 and common difference is 2 square. So what is it, guys? First term is 1, r minus 1, a plus n minus 1 into d, it is 2 square. So what is it? 2r minus 1 plus 1. So it is 2r minus 1 whole square. Or if you know it directly, that it is nothing but odd terms. Odd term, how do we represent? 2r minus 1, 2r plus 1. 2r minus 1, why? Because we start with 1. If you put r equal to 1, it will start with 1. So this is it. Now you got your TR. So what will be Sn? Sn will be sigma TR. Just open it. It will be sigma 4r square plus sigma 1 minus 4 times sigma r. But you see the amount of calculation here. You have to find out for sigma r square, sigma r. You will get it. So this is the method 2. But method 1 is easier, guys. Method 1 is far more easier. Okay. Let's solve next one. The sum of first 9 terms of the series. Okay. Now here also everything comes to the one point that we should be able to write all the general terms. We should be able to write general terms. Now see this. Is this confusing, guys? It is not at all. What is T1? T1 is 1 cube divided by 1. Okay. So T2 is 1 cube plus 2 cube divided by 1 plus 3. Okay. The sum of first 2 odd numbers. What is T3? T3 is 1 cube, 2 cube, and we go up to 3 cube. In the denominator, we have 3 odd numbers. So do you see this pattern? If it is 1, you are writing only one term. If you are writing T2, if you are writing second term, You see, we have got cubes of first two, 3 cubes of first 3, and in denominator we have sum of 3 odd numbers. So if it is TR, what is TR? TR will be 1 cube, 2 cube, 3 cube, 4 cube up to R cube, divide by 135. Now this is what? This is sum of first odd R numbers, 1 plus 3 plus 5 up to R, right? First R odd values. So this TR can be expanded very easily because we are aware of the results. We are very well aware of the results. Now this is sum of cubes of first R terms. So what is sum of cubes of first R terms? It will be R into R plus 1 whole square divided by 4. What is this? This is sum of first odd R terms. Sum of first R odd terms. That also we have a formula. Sum of first n odd numbers, n square. Sum of first R odd numbers. What is it? R square. So this will cancel out, and you see now how easy this has become. TR is equal to 1 by 4 R plus 1 square. Now instead of expanding it, see how many terms we want? First 9 terms. So Sn will be, S9 will be equal to 1 by 4 sigma R equal to 1 to 9 R plus 1 square. Right? Now when you put R equal to 1, this series starts with 2 square. Put R equal to 1, this becomes 2 square. Like this 1 by 4, 2 square, 3 square up to 10 square. Right? But the formula which we have is only valid if you start it with 1. Right? All those sigma formulas are valid only if you start with 1. So whatever term is missing, you add that. So this will be equal to 1 by 4, 1 square, 2 square, 3 square up to 10 square minus 1 square. So what is it, guys? 1 by 4 into, what is this value? N into n plus 1 into 2n plus 1 divided by 6 minus 1. So how much is the value here? This is 236, 5, 3 into 7. So 35 into 11, you can calculate it on your own. You got the answer. Is that clear? The only game is writing this TR. That's it. If you are able to write TR properly, your game is over. Because these manipulations are very easy to strike, but the most important thing is to strike how to write the general term. Okay? And that is why I am writing every single general term slowly, so that you can comprehend, you can understand what is the relation between this subscript and these are. That is what you have to only observe. Pattern, that is what you have to only observe. Okay? Solving next one. Okay. What is the question? The value of 16 to 30 is given is equal to. Now this is very calculative. You see, they start with 16. R equal to 16 to 30. And this is R plus 2. So multiply it. R square minus 3R plus 2R minus R minus 6. Right? R equal to 16, R square minus 3R plus 2R minus R. So now split it. So R equal to 16 to 30 R square minus sigma R equal to 16 R to 30 into R minus sigma R equal to 16 to 30 into 6. The problem is we cannot use the result. Why? Because R is starting from 16. We can use the result only if we start with 1. So what I'm going to do, I'm going to add and subtract those remaining terms. Like what is this? Is basically 16 square, 17 square up to 30 square minus what is this? 16, 17 up to 30. This is fine. This is minus 6 into how many terms? From 16 to 30, how many terms? B minus A plus 1. 30 minus 16, 14 plus 1, 15 terms. So this is done. Again, clearly see that series is not starting with 1. So add those remaining terms to complete the series so that we can use the formula. So 1 square, 2 square, I'm going to add till 15 square here, minus 1 plus 2 plus 3 up to 30, minus 90, minus what we are going to subtract, we added up to 15 square, 1 square, 2 square up to 15 square, and we added up to 15 here, 1 plus 2 plus 3 up to 15. That is, this is calculative, guys, because the problem is simple. So see, this is going to be calculative. What is it? 30 and into n plus 1, then 2n plus 1. So this will be 61 divided by 6, minus this is 30 and into n plus 1 divided by 2, minus 90 and minus, what is it? This is 15 and into n plus 1, 16, 2n plus 1 divided by 6. Oh, sorry, this is n into n plus 1, n into n plus 1 divided by 2. So that is it. I am not going to solve further because I don't have a space. You have to calculate it, because you can do it. No, this is 6 into 5. So 5 into 31 into 61, minus this, minus this. So calculation you can do it on your own. But this is how we are going to solve it. And these problems are going to take time. Only in the few last of calculation steps. Where general term is easy. See, there is nothing with the general term. The general term is given as it is. Only these manipulations are going to take time. You can complete this on your own. You can write the answer. Moving on, guys. Let A be the sum of the first 20 terms and be the sum of the first 40 terms of this series. Okay, guys, just look at the series. We have done it. And they want for the even terms, 20 terms, 40 terms. Okay, and we have written the formula. We have the direct result for this series. Otherwise, the calculation would have been far difficult. Okay, so b minus 2a is 100 lambda, then 100 lambda is equal to. So what is b? B is for how many terms? 40 terms. So we know the result. What is it? Guys, what is the result? Let me rewrite it. If you have forgotten, I'll rewrite for you. It is. Result is, if 1 plus 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square up to, for even number of term, even n terms, is equal to n into n plus 1 whole square divided by 2. This is the result we had written, and we are going to use it directly here. Okay, so 1 square, 2 into 2 square, what is it? For first it is 40 terms. So b minus 2a, what is b? B will be equal to, for 40 terms it is 40 into 41 whole square divided by 2, minus twice of a. A is for how many terms? For 20 terms. So n will be equal to 20. So 20 into 21 whole square and divide by 2. That is it. This is equal to 100 lambda. That's it. So what we can solve here? This is 20. So 20 into 41 square minus this is 20 into 21 square is equal to 100 lambda. What is it, guys? Take 20 common. So 41 minus 21, it is 20. And 41 plus 21, it is 62. Is equal to 100 lambda. So this 100 will cancel out. Lambda will be equal to 428, 46, 24, 248 is the answer. Is the answer. How easily we got it with the help of the result. But if you are not aware of this result, you see, first you will write general term, then we'll try to solve. Do remember it, guys, because this is the, like, if I observe past 10, 12 years questions or just 5 years, there has been a major pattern change in last 5 years. The type of question, initially it was too easy, but now they have been upgrading questions level in some papers. So this series will also now write it as a standard result in your notebook and memorize it. Not just in JEE Main, advanced also we can use it. Okay, let's solve next one. The sum of the following terms, 1 plus 6 plus this, up to 15 terms. Okay, up to 15 terms. Now the only deal is The only deal here is to write a general term, because it is looking very scary if you see the terms like this. But guys, it is not. It is not. You see that 1 and 6 are decepting. But if you see T3, here, it is giving you clear idea. 9 into 1 square, 2 square, 3 square, then 12. So this 9. This 9 has to be 3 into 3. This is third term. So this is 3 into 3. This is 12. This is fourth term, 3 into 4. This is fifth term, 3 into 5. So don't get decepted by that 1 and 6. Later on you can see 3 into 3, 3 into 4, 3 into 5. Okay? Okay. Then this series, the sum of squares is going up to subscript. Like this is T4. This is T4. This is T5. You can see this is going up to 5 square, 4 square. So we have observed what it mean by those two of the terms. After 3, the third term, you see 7, 9, 11. Again, these are odd values. So 11, and this is T5. So I can write 11 as 2 into 5 plus 1. Right? I can write 9 as, this is fourth term, 2 into 4 plus 1. That's all. We have established relation between that subscript R and the terms stands against it. So what is TR now, guys? Now we can write TR very easily. TR will be 3 into R into 1 square, 2 square up to R square, divide by, it is 2R plus 1. 2R plus 1. That's it. Very comfortably we are able to write a general term. Now expand it and solve. What is it? This is 3R multiplied sum of our terms, square of the terms. So this is R into R plus 1, 2R plus 1, divide by 6 into 2R plus 1. So what is cancelling? See, this 2R plus 1 cancels out. What is it that we have? This TR comes out to be, this is R cube, right? This is R square. So this is R cube plus R square, divide by 2. We got general term in the simplest form possible, and the game is over now. What is an SN? They want S15. So it will be equal to sigma R equal to 1 to 15 R cube plus R square, and the 1 by 2 will be outside. You can split it as two different sigmas. You can write it as 1 by 2 sigma R equal to 1 to 15 R cube plus sigma R equal to 1 to 15 R square. And we have direct result for these two. So substitute the result, calculate it, you have your answer. Right? What is the only challenge here is this. This is the only challenge in this problem. Writing general term properly. And you see, every time I am going to follow the same procedure. I am writing T1, T2, T3, T4, and then I am trying to establish the relation between that subscript and those values. Clear? So calculate it, you can mark your answer. Let's solve next. Okay, there is space left after every question, but I am too lazy to calculate answer. It is up to you. This is your job. Okay. The sum 3 into 1 cube by 1 square, 5 into 1, the same thing. Let's write the general term. So what is T1? This is T1. Okay, this is T1. We can see 1 square, 3 into 1 cube. Fine. Then this is T2. So second term. So this is sum of two terms, and this is sum of cubes of first two. Then after 3 we have 5. This is T3. We got 7. So it is a continuous odd number, 3, 5, 7. Sum of 3 cubes, squares, and sum of 3 cubes. So that's all. What is TR? That is the pattern. What is the TR? TR is, this is odd, like 3, 5, 7. This is odd, continuous odd values. So what will be rth odd value? 2R plus 1. 2R plus 1. Rth odd value will be 2R plus 1. Then it is sum of cubes up to the subscript 3. So it is up to R, 1 cube, 2 cube, up to R cube. Denominator is sum of squares up to that number. So 1 square, 2 square up to r square. That's it. That's it. Let's calculate this value. So this is equal to 2r plus 1 multiplied by, what is it? Sum of cubes. That is r into r plus 1. So this is r square, square divided by 4 into 1 square, 2 square, r square, r plus 1, 2r plus 1 divided by 6. So that's 6. We can later on multiply in the numerator. So guys, what is it? 2r plus 1 cancels out, r cancels out, r plus 1 also cancels out. So we have 6 by 4, which is 3 by 2 times r into r plus 1. And we don't need to have any special result, because okay, they have not mentioned terms. Okay guys, the question is incomplete. The question is incomplete. They have not mentioned number of terms, but I hope you got it. So what will be Sn now? Let's write Sn. Later on you can put value of n. So 3 by 2 r equal to 1 to n r into r plus 1. And this is also a standard result. You don't need to calculate r square plus r cube. This is a standard result. What is it? This is equal to 3 by 2 times n plus 1, n plus 2 divided by 3. We have standard result for such general terms. And that is why it is important to remember. Otherwise, you would have wasted 10, let's say 30 seconds of your calculation time here. Clear? Remember all those results. Fine. And I don't know the n value. Actually, I forgot. I think it was 10 or something else. Fine. Let's solve next one. What is it? K equal to 1 to 20 is equal to, and this is from 2020. 1, 2, 3 up to k, we know what is it. This is k equal to 1 to 20. What is it? It is k into k plus 1 by 2. See, again we are going to use our result. So this is 1 by 2 times sigma k equal to 1 to 20 k into k plus 1. We have a direct result. It is n into n plus 1, n plus 2 divided by 3. And what is our n here? N is 20. So put it 1 by 2. So 20, 21, 22 divided by 3. So this is 10. This is 7. So 7 to 4, 15, 1, 5, 4. So you see how easily, how quickly we got the answer just because we are well known with the results. This is the advantage if you are well known the results. Hardly 20 seconds. Hardly 20 seconds we took to solve this problem. Okay, answer is 1540. Clear? Okay, solving next one. N equal to 1 to 4. Now this is going to be calculative, guys, because we have n plus 1 and then 2n plus 1. Okay, so what you can do here, we can write it. Sigma n equal to 1 to 7. N into n plus 1, 2n plus 1. So this is 2n. Let's multiply and split. 2n into n plus 1. Divide by 4 and plus sigma n equal to 1 to 7. Okay, n equal to 1 to 7. And this is n into n plus 1 multiplied to this one. N into n plus 1 divided by 4. So this is direct result. We know how to solve it. This part we have the direct result, but here we have to do some mazduri. We have to do some labor work here. So 1 by 2 sigma n equal to 1 to 7 multiplied n square n cube. So it is n cube plus n square, right? N cube, this n square, n cube plus n square, and plus this we can write, this is equal to what? N into n plus 1, n plus 2 divided by 3. So 3 into 4, 12. Direct result. But here we need to solve. So 1 by 2 into, what's n cube? N into n plus 1. So n plus 1 is 8. 8 square divided by 4 plus. This 1 by 2 into, this n square will be n into n plus 1 into 2n plus 1. Divide by 6. And plus how much is this? This is 7 into 8 into 9 divided by 12. That's it. That is it. You need to calculate it. You can calculate. What is it? This is 8. So this is 7 square into 8 plus this is like 6, right? So 3 into 2, 6. This is 5. And then we can cancel out 2 to 4. So this is 2. So 5 to 10, 70. And plus, this is 8, 9, 72. So 9 into 8, 72, which is 6, 42. Right? So 7 square, 8, 70, 42. You can calculate. Now you can calculate. Okay, so that is how we make these things easier. If you don't have any result, try to get, like here I split it to use at least one of the direct values. Otherwise, if you directly multiply, there is no such thing here. You could have directly multiplied and solved. Okay, solving next one, guys. Sum of the series 1 plus 2 into 3. 1 plus, so T1 is 1. Right? 11th term, up to 11th term. We have to find sum up to 11th term. So let's write the general term first. T1 is 1. T2 is 2 into 3. Fine. T2 is 2 into 3. T3 is 3 into 5. Fine. T4 is 4 into 7. Do you see now? Subscript is 2. So that is 2 and this is odd value. Subscript is 3. 3, then odd value. So this is 3, 5, 7 kind of an AP going on. So what is TR? TR is 2, 3R. R into, and this is general term. This is general term or Rth term. Right? Rth term of AP 1, 3, 5, 7. Or see, you can, instead of like thinking of the AP, what you can think directly is that this is all, these all are continuous odd. So we know how to write odd. 2R plus 1, 2R minus 1. Whatever fits, just use it. So 3, 2 into 3 minus 1. 2, this is 3. How it is? It is 2 into 2 minus 1. What is it? 2 into 3 minus 1. What is it? 2 into 4 minus 1. So this is fits. This is fitting. 2R minus 1 is fitting. So that's all. TR is R into 2R minus 1. So sum up to 11th term we want. S11 will be equal to sigma R equal to 1 to 11. This is twice of R square and minus sigma R equal to 1 to 11. This is only R. So that's it, guys. You replace the values up to 11. So R square will be n into n plus 1. N into n plus 1 into 2n plus 1. So it will be 23 divided by 6 minus n into n plus 1. 11 into 12 divided by 2. Calculate it. 2 into 3, 6. 3 into 4, 12. So this is 44 into 23 and minus this is 66. Right? 2, 6, 66. We can take 11 common. So 24 into 3, 92 minus 6. So 11 into this is 86. So this is 6. 946 will be your answer. Okay? 946 is the answer. That is why I'm avoiding calculation, because my intention only is to teach you writing general term. Right? That's all. That is my only intention here. Because if you have idea how to write general term, these sigma problems will be like this. One of the easiest thing you will see in your entire paper. Okay? Let's move to the next question. So 1 plus 1 cube plus 2 cube. Now this is like one of the simplest thing to understand, like what will be the sum. And this is up to 15 terms. You can clearly see. This sum here is up to 15 terms. And there is a minus also. Minus 1 by 2 up to sum of 15. So let's write it. I'm not going to write this time directly. What is it? It is sigma R equal to 1 to 15. R cube. It is like 1 cube, 2 cube, up to R cube divided by 1 plus 2 plus up to R. This is it, right? That is it. Sigma R cube divided by R. This is the general term. Minus 1 by 2. Sum of 15 numbers, which is n into n plus 1 divided by 2. So what is it, guys? Sigma R equal to 1 to 15, 1 cube, 2 cube, 3 cube up to R cube. That will be R into R plus 1 by 2. So it will be R into R plus 1 square divided by 4. And this is R into R plus 1 divided by 2. This cancels out. Minus this is 4, 15, 4, 60. So So that's it. The take 1 by 2 out. Sigma r equal to 1 to 15. This is r into r plus 1 minus 60. And again, guys, this is a standard result for us. R into r plus 1. What is it? 1 by 2. N 15. N plus 1 16. N plus 2 17. Divide by 3. Because this is 1. Okay. So r plus 2 divided by 3 minus 60. So can we cancel? 2 into 5, 8, sorry, 3 into 5, 8, 5, 40, 60. 8, 5, 40, 17, 4, 680 minus 60. So answer is 620 is the answer. 620, D option. So terrifying it had looked initially. So terrifying. Cubic, square. But these questions are the easiest one, guys. I don't think, even after I've calculated, I'm very lethargic in calculation. Still, I found the answer within a minute, right? Within a minute, we got the answer. And everything is dependent on this thing, like how well you are with this general term. This is the general term. This was general term. And if you have practiced these many sums, by now, you should be having a clear idea that I'm just relating with the last terms and the subscript. Like this was T3. This was T3. That is all. Okay. Moving on to next question, guys. Not the question. And the last topic for this chapter, which is method of difference, and one of the best methods, right? There will be chapters where we are having where we will be solving series problems, and that won't be only sigma r square sigma r cube. See, you are going to see series questions in trigonometry. You are going to deal with series problems in binomial. Okay, like there is a special pattern of questions where we deal with factorial, r factorial. That we'll do in binomial chapter. Okay. Then you will have series with some complex numbers. You can have series with there are so many things in with exponential, logarithm. Now all those series will not be dependent on sigma r square sigma r cube. So this is a universal funda to solve any series if it is not dependent on those three results, r square, r cube. Okay, method of difference. In fact, we derive those results using method of difference. We have derived sigma r square sigma r cube using method of difference itself. Okay, so just understand it, and this is quite simple. This is quite simple to understand. Like just by the name of it, method of difference, we are going to do as per the name says. We are going to write a general term in difference of two terms. Suppose a series is given. Okay, suppose we have to find out Sn, and there is a series. We have to find Sn T1 plus T2 plus T3 plus T4 up to Tn. So we are given with a series Sn. It goes from T1, T2, T3, T4 up to Tn, right? And it is not in the terms of sigma r square r cube. So we don't have a direct result. It is not even AGP also. We are clueless what to do. This is what we'll do. We'll write that. We'll find general term first, and we'll try to write as a difference of two terms. So I'll get general term. I'll get the general term first. Let's say general term TR, and the general term TR will be written as difference of two consecutive terms. They need not to be always like r minus 1. It could be r minus 2 also, or r plus 2 also. The only funda I want to explain here is that they will be as difference of two terms, consecutive. Okay, the difference should, if they are consecutive, it is like the best scene possible. If the difference is of 2, still fine. And like in general, you are not going to get difference more than 2. This is what you have to do. Fr minus 1 or Fr minus Fr plus 1. It will be function of r plus 1, r minus 1, or r minus 1, r minus 2, like that. Okay. Write that general term TR as difference of two consecutive terms. Write my sentence somewhere. Okay. You have to write general term as difference of two consecutive terms. After that, you see, once you have got it, so what is our Sn? Sn is, guys, sigma TR from r equal to 1 to n. So you will write it r equal to 1 to n Fr minus f of r minus 1. We have replaced it. Now start putting R values from 1 up to n, and there you will see the magic. There you will see the magic. Start putting values, guys. Put R equal to 1. Put R equal to 1. You will get F1 minus F0. Then this is sigma, so we'll add next one. So for R equal to 1, F1, 1 minus 1, F0. Now put R equal to 2. It will be F2 minus, put R equal to F1. Now put R equal to 3, F3 minus F of 2. Keep doing that. Put R equal to the last one n. So Fn minus F of n minus 1. Right? Now, do you see the cancellation happening? Without even any standard result, you will see cancellations happening here. You see F1, F1. Alternate terms are getting cancelled. F2, F3. So what is going to remain? The least and the greatest. This will also cancel out. The least and the greatest will have no pair at all. These two will remain. So the final answer here will be F of n minus F of 0. That's all. Sigma TR, this is your final result. And this is the like advantage of using method of difference. No matter what type of series is. If you can write them, if you can write general term as difference of two consecutive terms, ultimately you are going to get the result. And what is the result? Even the result also you can memorize. The result is the term having maximum input and the term having minimum input. That's all. Two terms will be left. You can see here. So R plus 1. So R is the greater one and this is the smaller one. The term having greatest input will be F of n, right? The term of greatest input will be F of n. And the term having least input will be this F of 0 with negative sign. So that's all. That's all. You can directly write. Just after writing it, you don't need to do this cancellation every time, right? What you can do, you can directly write the term having greatest input and the term having least input with their sign. Write it. So greatest input will be n for this, least input will be for this 0, Fn minus F0. That is your result. Clear? But the main problem is writing in terms of difference is not a kind of a thing which I can teach you. There are some pattern of problems where I can give you some idea, but not every time. It has to be your skills, your observation after solving few questions related to method of difference. But I cannot teach directly like standard approach for difference. It has to come from here. Okay, but I can show you some examples like how I am thinking, and there are some types where it is going to work everywhere, every time. Okay, let's start the questions, guys. So here we have to find Sn, and what is Sn here? Sn is 1, 2, 3, 2, 3, 4 n terms. So these are the types, these are the problems where my method is going to work. First thing, write general term. What is general term here? TR. Guys, TR will be 1 upon, this is R, R plus 1, R plus 2. So in these problems where we have the general term as a function of R in denominator, okay, there my method is going to work. If the general term is having products or factors of R in the denominator, there what logic you can use? The logic will be the logic to write in terms of difference. The logic to write as a difference will be this. Will be. It is going to be, guys, it is going to be write numerator as difference of greatest and least term of denominator. Right? Write numerator as difference of greatest and least term of denominator. And you are not supposed to change the general term. So balance constants. What I mean by balance constant, I'll show you. Okay. So here this is the TR, okay. Numerator is 1. We have to write numerator as difference of the least and greatest term. But you see, the least is r, the greatest is r plus 2 here. Their difference is 2. The difference is 2. The difference is 2, guys. That is what I mean by balancing constant. Difference is 2, but it is 1 here. So we need to first multiply and divide 2. So 2 divided by 1 by 2, r plus 1, r plus 2. This is the first step. Writing numerator as difference of greatest and least term. So first I have made that difference. The first step, make that difference in denominator first. Like balance all the constants. So we got it. Now write that 2 as difference of greatest and the least of denominator. So r plus 2 minus r divide by r into r plus 1 into r plus 2. After that, split it. The difference that you have written, split them. So this is equal to 1 by 2 times. So this will be r plus 2 divided by r into r plus 1 r plus 2 minus r divided by r into r plus 1 r plus 2. Right? So r plus 2 will cancel out and r will cancel out. So this comes out as 1 by 2 times 1 upon r into r plus 1 minus 1 upon r plus 1 into r plus 2. We got it. And these are conjugative. Guys, can you see? R plus 1, r plus 1, r plus 2. Conjugative terms. That's it. That's it. That is what we wanted. We wanted to get that general term as a difference of two terms. And we have got it. We have got it. The problem is 90% solved. That is what we wanted, guys. Now to solve it up to n terms, the next step will be, what is the next step? Now that we have got TR, what is Sn? Sn is sigma 1 by 2 this TR, 1 upon r into r plus 1 minus 1 upon r plus 1 into r plus 2. So either you can write few terms and see what will be the final answer, or you can remember my funda. Which all two terms will be left? The term with greatest input and the term with least input. Now you can see this is lesser and this is greater. I'm talking about the denominator. When I say greatest and least, I mean by the terms dependent on r. So when I put these r values, r is from 1 to n. Okay. So when I put those values, you see which term is going to get the greatest input? This one. This is the greater one. So this is going to get the greater input, right? The greatest input is n. So this will take the greatest input n. And the least one will be this when r is 1. So this Sn finally is equal to 1 by 2. This will get the least input, which is 1, r equal to 1. And the greatest input in the greater of that. So 1 upon 2 minus 1 upon n plus 1, n plus 2. That's all. This is your answer. That is your answer, guys. Okay. The last step is always, see, this is least value of r, this is greatest value of r. Least value of r is 1, greatest value is n. So the least will be, you will be putting least value in the least of the r values, and the greatest of n, the greatest of r will be substituted in the greater denominator. Okay. Maximum value of r will go towards the maximum valued denominator, and the minimum value of r will be substituted in the denominator which is having lesser value. So if you compare r plus 1 and these two, obviously this is greater, this is less. Okay, so the lesser one got the lesser r and the greater one got the greater r with their signs maintained, negative. That is all. Okay, if you have any confusion, write few terms, see how they cancel out, you can write it. Okay, I hope you got it. Let's solve the few terms, questions which were asked in previous years. So this was asked in 2015, you see, and the general term, you can see the general term is quite what we have just done. The general term, the denominator is function of a continuous product, so we know how to solve it. The numerator will be difference of the greatest and the least, and that difference is 3, n plus 3 minus n, that is 3. That Sn will be sigma n equal to 1 to 5. The difference is 3, so I need to multiply 3 and divide 3. Divide by n plus 1, n plus 2, n plus 3. Now I'll write it as 1 by 3 sigma n equal to 1 to 5. This 3 will be written as greatest minus least. N plus 3 minus n divided by n plus 1, n plus 2, n plus 3. I can split them now. Let's split it. 1 by 3 n is equal to 1 to 5. Split it, guys. So if you split it, n plus 3 will cancel out. 1 upon n plus 1, n plus 2 will remain. Minus this n will cancel out. 1 upon n plus 1, n plus 2, n plus 3 will remain. And this is difference of consecutive terms. So you can write your final answer 1 by 3 into. You can write your final answer afterwards. What to do? Least value of r in the lesser denominator. Clearly, this is lesser and this is greater. Right? If you compare these two. So, least value of r in the lesser denominator. Least of r, which is n here, is 1. So, 1 upon 1, 1 plus 1, 1 plus 1, 2, 1 plus 2, 3. Minus maximum in the greater one. So, 5 plus 1, 6. 5 plus 2, 7, and 5 plus 3, 8. This is your answer. This you can calculate. What is it? You can calculate it, guys. So this will be equal to 1 by 3. 1 by 3 times 1 by 6 minus 1 upon. 1 upon, or let's say 1 by 6 also we take common. So it will be 1 minus 1 upon 56. So this is 18, so 55. So 55 divided by 18 into 56. That is 55 divided by. This is 18/6. This is 18 into 56. Right? So we can multiply and write it. So what is it? What is it? 18 into 6. So 18 into 56, you can do it, you can calculate it. 55 upon something, I think this will be your answer. C option. 55 upon 336. And this is JEE main problem. You see, the fund of splitting, if you are well with that, you can write your answer within seconds. The only that calculation will take time, nothing else. Clear, guys? Let's solve few more. Let's solve few more. And mind it, every time you are not going to come across this type of problem. There can be something different also. This is only going to work. Greatest minus least is only going to work if the denominator is product of linear factors. Okay, denominator is product of linear factors. There is it going to work very smoothly. But if it is something different, like in factorial ones and something else, we'll see it. We'll see some questions like that. Okay, so again, very complicated looking general term, but when we simplify it, it will be easy. And now we are pro at writing general terms. So guys, just by looking, you see T1, T2, T3. This is T1, this is T2, this is T3. What is TR? TR will be equal to 1 plus 2 plus up to R divided by 1 cube, 2 cube up to R cube. So this will be equal to R into R plus 1 divided by 2. And what is it? R square. R plus 1 square by 4. So this is 2 upon R into R plus 1. That's it. Product is, the denominator is product of linear factors. Best for us. Best possible scene for us. So what will be Sn? What is Sn? Sn is sigma. Take 2 outside. R equal to 1 to n. And this is 1 upon n R into R plus 1. We know how to write it is difference. We can write 2. R equal to 1 to n. Numerator is 1. So that 1 will be written as difference of greatest minus least. So it will be R plus 1 minus R divided by R into R plus 1, which is equal to twice of sigma R equal to 1 to. Now I'll split. I'll split with R plus 1 and R. So R plus 1 cancel out. 1 by R minus 1 by R plus 1. Even after that, the final answer is also easier to write. What is least? This is lesser. This is greater. So put the lesser value of R. So this is 2 into 1 minus 1 upon n plus 1. So you calculated, this becomes 2 n plus 1 n upon n plus 1. We got it? Sn is 2n upon n plus 1, right? Now what is it given to calculate? 100 Sn is n. Okay. 100 Sn is n. So 100 into Sn is 2n divided by n plus 1, that is equal to n. And n will cancel out. So n plus 1 is 200. N will be equal to 199. 199 is the answer, guys. A option. That is it. And see, almost the problems in JEE mains are like these. Those problems where we have to use factorial, we'll see how to do them, how to solve them in binomial chapter. But if you have general terms in these forms, no, you are going to kill it within seconds. If you have understood how are we subtract, like how is the splitting method working, if you are able to understand that, like you are going to solve it for sure. Okay, let's solve next one. 3, 5, 7 up to 11 terms. So we can write general term now. What is TR? 3, 5, 7. So this is odd terms, right? Odd terms. So this is 2R plus 1. How? 3 is 2 into 1 plus 1. 5 is 2 into 2 plus 1. 7 is 2 into 3 plus 1. So 2R plus 1 divide by up to 1 square, 2 square, up to R square. That is it. 1 square, 2 square, 3 square, up to R square. So what is this going to be? 2R plus 1 divide by R plus 1. 2R plus 1 divide by 6. That 6 will go into numerator. Almost same. 6 divided by R into R plus 1. You see, this easiest possible general term we have got. The easiest possible general term. And we have just done this splitting. So I'll write the result. This Sn will be equal to sigma TR. And since we have just done in the previous problem, I'm going to write it the result 1 minus 1 upon n plus 1. That is it. How many terms? 11 terms. So S11 will be equal to 6 into this is n upon. So 11 upon 12. So answer will be 11 by 2. D option. 11 by 2 will be answer. This type of general term you are going to see in many problems. But we know how to simplify it. Okay guys, moving to next. Okay, so let's solve this question now. 1 upon 3 square minus 1, 5 square minus 1. So we can relate it. This is T1. This is T2. This is T3. Right? So this is 2 into 1 plus 1, 2 into 2 plus 1, 3, 5, 7 guys. 3, 5, 7, 9. Odd values. Odd values. So what are we even thinking for? We can write TR directly. That TR will be 1 upon 2R plus 1 whole square minus 1, which is equal to 1 upon A square minus B square. So it is 2R into 2R plus 2. 2R plus 2. Exactly the same thing we have been doing from past 3 questions. R into R plus 1. R into R. This TR is our favorite. Like we have been solving this TR from so many problems now. So like how many terms guys? This is 201. So 201, that means this must be 2 into 100 plus 1. So this means we have to, this is T100. Right? This is T100. So we started from T1 to T100. There are 100 terms here. So Sn will be of 100 terms. So S100 will be sigma R equal to 1 to 100, 1 by 4, 1 upon R into R plus 1. And in last 3 questions also we have solved the same sigma. So I'm going to directly write that expression. This is 1 by R minus 1 by R plus 1. We know how to write in difference. If you have not seen the previous one, go back and see those 3 problems. So this is 1 by 4 into. Now should I write the direct final answer? This will be 1 minus 1 upon 101. That is 1 by 4 into 100 divided by 101. So this is 25. So the answer is going to be 25 divided by 101. 25 divided by 101. B is the correct answer. And this is asked in 2021. But you see the pattern guys. Every time it is the product of factors in the denominator. How simple the problem is if you have got general terms like this. Okay, so I hope you are getting it, and please don't have any confusion regarding these general terms. If you have any, watch those slides, watch that section of the lecture again if you are uncomfortable with general term. Okay, then let's solve the next question. Alpha beta are natural numbers such that 100 to the power alpha minus 199 beta is equal to this sum. And the slope of the line passing through alpha beta. Okay, so now just look at the series 100, 100, 99, 101, 98, 102. So what will be general term here for this series? Like for this series, what will be general term? That is the only challenge, right? 100, 100, starting from 100, 100, 99. You can see it in the reverse order also. 1 into 199. So, so can I say that this is equal to this TR here? This TR for this is equal to sigma 100 minus R into 100 plus R, like this. And it goes from where to where? R is from 1 to R is from 1 to or 0 to 99. Now I think this will work now. See, put R equal to 0, you get first term. Put R equal to 1, 100 minus 1, 100 minus 99, 100 plus 1, 101. That's all. This is the general term. We got it. So this is equal to sigma R equal to 0 to 99, and this is 100 square minus R equal to 0 to 99 R square. So how many terms? 0 to 99, 100 terms. 0 to 99 because B minus A plus 1. 99 minus 0 plus 1, 100 terms. So this will be equal to 100 cube and minus what is this? What is this? 0 square, 1 square. So 1 square, 2 square up to 99 square. So we know how to solve it. This is 100 cube minus n plus 1, 2n plus 1. So that will be equal to 199. Divide by 6. So we got beta, we got alpha. Now we have to compare, like this is equal to 100 to the power alpha minus 99 beta, right? 199 beta. So guys, I think you can compare now. What is alpha and beta? If we compare, alpha will be equal to how much? Alpha is 3. And what is beta? Beta is equal to how much? That is 99 into 100 by 6. 99 into 100 by 6. We got alpha beta. So they are asking what is slope passing through alpha beta and origin. So that slope will be beta by alpha. That is 99 into 100 divide by, this will be 18. So you can simplify it a bit. This is like 3 into 6, 18, and this is 33. Then 3 into 2, 6, 11. So 1100 divided by 2, that is the value of slope. Okay, so again the only thing which was slightly smart here was writing general term in this way. If we can write general term in this way, the question is taking very less time to solve. Clear? It's only about general term. If you are able to figure out properly, you are going to solve it definitely. Okay, moving on to next term, guys. So A1, A2, A3 B is AP such that n equal to 1 to 20 is 4 by 9. Some of this is AP. This is in division, right? So this is giving you some vibe of method of difference, right? Like what is this? A and n plus 1. So this is sigma n equal to 1 to 20. If you write the general term, what is it? A and n plus 1. You see the difference will be what? The difference will be d. So can I write d and 1 by d into an plus 1? Because this is a AP sequence. So an plus 1. What is it? That is the conjugative term. And what is the difference? See, we always make difference in the numerator. So what is difference of an plus 1 an? It is the common difference d of that AP. So that we have framed it. So 1 by t, now I can write it sigma n equal to 1 to 20, and this d I am going to write it as an plus 1 minus an divided by an into an plus 1, and this will be equal to 4 by 9. right? What is common difference? Sum of this AP is 189. Okay, we are not given this. We are not given with the D thing. So we have to get two relations here in terms of A and D. So guys, what is this going to be? 1 by D times. If you simplify it, this is sigma n equal to 1 to 20. Cancel it. 1 upon an, 1 upon an plus 1 is equal to 4 by 9. Now you know the logic. Least in the lesser one. So this will be 1 upon a1. Greater in the greater one. So this will be an. Right? So it will be a21. And this is equal to 4 by 9. So a21 minus 1, what is it? What is it, guys? a21. So this is 1 upon d into a21 minus a1 divided by a1 into a21. a1 into a21 is equal to 4 by 9. So write everything in terms of d. So let's say a1 is a and the common difference is d. So 1 upon d equal to a21 will be a plus 20d. So it will be only 20d in the numerator. a1 is a and a21 is a plus 20d. And that is 4 by 9. Right? So dd will cancel out. This is 5. So we have a into a plus 20d equal to 45. We got this relation somehow. A into a plus 20d is equal to 45. Now sum of this AP is 189. Sum of this AP is 189. So what is the second relation? What is the second relation? Sum of this AP, how many terms are there? 21. So 21 by 2 into 2a plus 20d. There are 21 terms. So this is equal to 189. So I think we can cancel it 9 times. So this is 2a. So a plus 10d is equal to, this is 9. So this is second equation. So using 1 and 2, you can clearly find out common difference d, common difference a, and then you can substitute to find a6 into a16. Now a6 will be a plus 5d, right? Let's see if we can find out directly. A plus 5d into a plus 15d. I think we have to go for finding a and d both, right? So there from these two, find a and d and substitute it here. From a plus 10d is how much? 9. You can replace here a plus 10d is 9, 9 plus 10d, and then you can solve. Clear? Replace d or replace a. We have two equations, two variable, you can simplify it. So find it and replace it. But we have used the method of difference and how to get into this form. What has helped that particular logic, that write numerator as a difference of denominator terms, the greatest and the least. Here we had only two terms. That is what we did. Okay, so I hope all these fundas, all these methods are being clear to you. Moving on, guys. Moving to next question now. Guys, so let's solve this problem. Now again we have the general term. We have to write here. We have to find out sum of 10 terms. So general term, guys, what is it? 2 into 1 plus 1. These are odd. So we have been writing for so much time. TR will be equal to 2R plus 1 divided by RR plus 1. R square R plus 1 whole square. And guys, this is the beauty of this question. You see, the general term is given in such a way that the numerator is difference of these two. And that is what we always try to make. We try to make that numerator as the difference of denominator. It is already given as a difference. So I can write TR. As this 2R plus 1 is nothing but R plus 1 whole square minus R square divided by R square into R plus 1 whole square. So what is it? We just split it. So it becomes 1 upon R square minus 1 upon R plus 1 square. Right? So Sn will be sigma R equal to 1 to 10, 1 upon R square minus 1 upon R plus 1 whole square. So again the terms are conjugative, right? The terms are conjugative, R plus 1. Square is there, but obviously cancellation will happen. So we can write our final answer. What will be S10? So minimum value of R in the minimum one. So 1 upon 1 square minus the maximum of R in the maximum one. So minus 1 upon 10 plus 1, 11 square. That is your answer. 11 square minus 1 square. What is it? 11 minus 1, 10. 12 divided by 11. So 120 divided by 11 is the answer. 120 by 11. And there is no such answer. Oh, 11 square. Sorry. My mistake. This is 11 square, which is option P. Clear, guys? So that there's something there. We had something different here. We had something different. We had some different general term here, but the funda was exactly same, that we write numerator as difference of denominator. The greatest and least term of denominator. Here we had only two terms, so we had written as a difference. Fine. Let's solve the next one. Now this is also slightly weird type of series. X equal to 2, we had to solve this, and this is S. So guys, if I solve, what is 1 upon x plus 1 minus S? If I subtract x minus 1, sorry. See, the type of denominator we have here, x square, x power 4 plus 1. So I think they can combine. These terms can combine. If I get them a minus b, a plus b is there. Somehow if I can get a minus b, the terms will start combining. And I think I can do that. If I subtract 1 upon x minus 1 from this series, what is it going to be? 1 upon x minus 1 minus 1 upon x plus 1 minus 2 upon x square plus 1 minus 2 square upon x power 4 plus 1 and the other terms. So this will be x plus 1 minus x1. This will become 2 upon x square minus 1. Right? We solve these two. This will be x plus 1, 2 upon x square minus 1. Minus 2 upon x square plus 1. Minus 2 square upon x power 4 plus 1. And this will keep on going. So now you combine these two. So x square plus 1, x square minus 1, this will cancel out. It will become 2 square. Divide by x power 4 minus 1 now. Right? Because a square minus a plus b into a minus b, x power 4 minus 1 minus 2 square divided by x power 4 plus 1 and minus other terms. Guys, do you see here what is happening? This is 2 square again 2. So it will become 2 cube upon x power. This will be a power b is 4 power 8. So x power 2 power 3 minus 1 minus. What will be next term? Next term will be 2 power 4. 2 power, I think 3 only. Right? This was 2 square, so 2 power 3. Divide by x power 2 power 3 minus 1. So do you see the terms are combining? How they are combining, right? 2 square. So what we can write? We can write the final result. This is going up to 100. So if you write up to 100, what will be the last one? You see, they combine and to give one more. So this will become 2 power 101 divide by. This is 2 power 100. So this will be x to the power 2 power 100, right? So 2 power, this will become 101 because this will be into 2. So 2 power 101 minus 1. This is it what we'll get. 2 to the power 101. So now you can find out your S. The series S will be equal to 1 upon x minus 1, which is 1. Right? Put x equal to 2 there. Put x equal to 2. So it will be 1 minus, and this whole thing, 2 power 101 divide by 2 to the power 101 minus 1. This is what the series will be. Right? Which is 4 power 101. So I think you got the answer. Excellent question, right? Something different, and it is the see. This is from 2021. And these are the types of problems which you are supposed to leave if you are not good with method of difference. Okay, this is the one variety where we have like see how it's right, because the terms had scope of combining. So that is what I tried. I just gave them a plus b was there. I just gave them a minus b, and everything started to combine. Okay, so this was slightly different, but I hope you have understood it. Let's solve the next one, guys. Okay, so till now we have been dealing with the problems where we are taking difference, writing terms as a difference. Here also, like this is one variety where the difference, the first difference will be AP. This is a variety where first difference is AP. You can see 7 minus 3, 4. 14 minus 7, 7. This is 10. This is how much? 13. So 4, 3, 3, 3. So the difference is in AP, guys. So if that difference is in AP, see, the funda remains same. To solve these questions, what you have to do, we had to find general term. And to find general term, we'll go for method of difference. Here, we'll subtract the series to find Tn. See how I'm going to solve this. I'll write Sn. What is Sn here? 3 plus 7 plus 14 plus 24 up to Tn minus 1, Tn. N minus 1th term, nth term. Now, if I write this series only for let's say how many terms? Or let's write the series, same series, now by shifting one term to the right. 3, 7, 14 plus Tn minus 1 plus Tn. Right. This is how I have written the series. Same series but shifted by one term. Now if I subtract, guys, if I subtract, see what will happen. If I subtract, this is 0, 3, 7 plus 3, 4, 14 minus 7, 7, 24 minus 14, 10. And the subtraction will keep on taking place till here. Like starting from second term. The subtraction started from second term, it kept on going till nth term. From T2 to Tn. Now that difference is always going to be known. It is always same. It is it is going to be an AP 24 minus 14, 10. Next will be 13, and this will be plus Tn minus 1, then minus of this Tn. This has no such pair. It will be written as it is. Now, guys, we have a AP here. We have a AP from the subtraction of the terms from T2 to Tn. So can I say that these all terms, this is a AP of from second to nth, that is this is A plus B, right? A plus B minus, this is A minus B plus 1. So it is n minus 1 terms. This is very important to understand here. When I am subtracting the series, I'm getting a AP of n minus 1 terms. So this starting from 4, when the first difference started till the nth difference, we have got this. We have got a AP, right? So if you take that Tn into LHS, so what is that Tn now? 3 plus n minus 1 terms are there. So write sum of AP, number of terms by 2, 2a, 8 plus n minus 1, which will be n minus 2, into common difference 3. Okay, so guys, this is 3 plus n minus 1 by 2 into what is it? This is how much? This is 3n. This is 8 plus, right? Is fine, yeah. 8 plus this 3n minus 6, so it is 3n. It is 3n minus 6, so 3n plus 2 divide by 2. Number of terms divided by 2, 2a 8 plus number of terms n minus 1 to d, which is 3. So 3n minus 6, 8 minus 6 plus 2. Correct? So this is equal to how much is this now? I think if you multiply them, so this is 3 plus, this is 3n square plus 2n minus 3n. Okay, this is 3n square plus 2n minus 3n, so minus n, and then this is minus 2, and this will be 2 into 3, 6 divided by 2. This comes out as 3n square, right? 3n square, 2n minus 3n minus n, this is fine, minus 2. So 6 minus 2, 4. Minus n minus 4 divided by 2. This is our general term. And I think here if you start putting values, you are going to get it. Put n equal to 1. So 1, 3 minus 1, 2 minus 4. Okay, I think there is some calculation error, guys. There is some calculation error. Let me see, where is it? Where is the calculation error here? 3, 4, 7, 10 and minus 1 terms. Okay. First term was 3. 4, 7, 10, fine. So n minus 1, number of terms by 2, 2a plus n minus 1, difference is 3. So that is fine. So 8 plus, this is 3n minus 6, 2a plus n minus 1 into d, this is fine, 3n minus 6. So 8 plus 6, 2. And this is by 2. After that, if you multiply, so this will be, okay, this is 4, sorry, this is 4, plus 4. 6 minus 2 plus 4. Now if I put n equal to 1, 3 minus 1, 2, 2 plus 4, 6, 6 by 2, 3. We got first term. Put n equal to 2 here. 2 square, 4, 4, 3, 12. 12 minus 2, 10. 10 plus 4, 14 by 2, 7. Second term we got. Put n equal to 3. Put n equal to 3, 3. 3 square, 9. 9, 3, 27. 27 minus 3, 24. 24 plus 4, 28 by 2, 14. That's all. We got the general term. So this difference is only to get the general term. 3n square minus n plus 4. So now that you got Tn as 3n square minus n minus 4 divided by 2. So basically we got general term 3r square minus r minus 4 divided by 2. So the first difference has given you a general term. Now that you have general term, you can find sum. What will be Sn? Sn will be sigma tr. That will be equal to sigma 3 by 2 r square minus 1 by 2 sigma r minus sigma 4. And all these are known to you. Right? So this Sn will be equal to 3 by 2 into sigma r square n plus 1, 2n plus 1 divided by 6 minus, this is will be n plus 1 divided by 4 and minus 4n. You can simplify it, but I hope you have understood the logic, right? That is very critical step, that the difference, guys, the first difference is only done to get this general term. By taking help of the fact that by subtracting we are going to get a AP. And how many terms, that is also known. So by that you take that Tn into LHS, we got Tn from here, right? We are taking this Tn. We have taken this Tn into LHS. So that we got Tn, and after that we found out the general term. We got Tn, we got Tr, Sn is sigma Tr, we did that and we got it. Now this is excellent question. Obviously you will see it in exams also. And what is the what is the method to identify? The difference was AP. When difference is AP or difference of difference is AP, there you can use this. When difference of difference is AP, you need to take difference 2 times to get general term. Here first difference is giving you general term. But if difference of difference is AP, you need to take difference 2 times. Okay? Complicated, but I hope you understood. In the similar way, we have one series where the difference gives you a GP. Like here, I'll not solve it entirely, I'll leave it up to you. I'll show you just few steps. 4 minus 1, 3. 10 minus 4, 6. 22 minus 10, 12. So what is it? 3 into 2, 6. 6 into 2, 12. So this is a GP which you are getting. You are getting a GP series. So we can simplify it. Same way. Like Sn is equal to 1 plus 4, 10, then 22, the other. Tn minus 1 plus Tn. So what will be Sn minus 1? Sorry, Sn again by shifting one term to the right. 1, 4, 10, Tn minus 2, Tn minus 1, Tn. And now take the difference. When you take the difference, you are going to get one GP series here. What is it? This is 0, 1, 3, 6, 12, right? This difference is giving you GP. So the difference till this, from second term to nth term, you are taking difference, and that difference is giving you a GP sequence. So 3, 6, 12 up to n minus 1 terms minus Tn. Take that Tn into LHS. So Tn is equal to 1 plus. Now you can solve this series. What is it? A into 3, A into r to the power n. Okay. What is common difference? Common difference is 2 here. The GP of n minus 1 terms, common difference is 2. So 1 plus a into r to the power n minus 1 divided by r minus 1, which is 1 itself. That's it, guys. We've got Tn. Tn is how much? Tn is this is 3. So 3 into 2 to the power n minus 1 minus 2. We got Tn. So we got Tr also. 3 into 2 to the power r minus 1 minus 2. So Sn will be sigma Tr. So you have to solve only a GP, right? 3 into sigma 2 to the power r minus 1. R is from 1 to n, and minus this will be 2n. That's all. We can calculate it afterwards, but I have shown you the way that when you take difference, you are going to get a series which is a GP. You solve that GP, you get general term. Guys, here we are taking first difference just to get general term, because once general term is known, Sn is sigma Tr. Okay. Now this series has never been in exams, but maybe if they give it, you will have a clue. Now there is a, like, see, all these things we can remember also. Remember, whenever difference, the first difference series in AP, then you can take Tn equal to n square plus bn plus c. You can directly write Tn equal to n square plus bn plus c, and you can solve for ABC, like in the first question here. In the first question, like I knew that the difference is in AP. The difference series, this is the difference series 4, 7, 10, 13. So what they are telling, that you can directly start with taking Tn is equal to an square plus bn plus c, and we can find ABC. And how can we do that? See, first term is 3, so put n equal to 1. So T1 is a plus b plus c, and that is equal to 13. Oh, sorry, 3. Put n equal to 2. So T2 will be equal to 4a. 4a plus 2b plus c, and that is 7. T3 is equal to 9a plus 3b, which is equal to 14. So 3 equations, 3 variable, you can solve for ABC. From here, you'll get a equal to 3 by 2. You'll get b equal to minus 1 by 2. You'll get c equal to, this is I think 2. This is how you are going to get it, right? If first difference, the difference series in AP, this is how we write Tn, an square plus bn plus c, and that will simplify your, like this simplification will be like you can skip it, you can directly go to this thing and you can find ABC. But finding ABC or finding general term is equally, like you will not have a much difference of effort here. Okay, so it's better to remember this questions in this way. Okay. The second point was difference of difference series in AP, then you just increase it. See, when the series is AP, what is Tn? Tn is an plus b. When difference series is AP, then an square plus bn plus c. When difference of difference is in AP, then just one more, an cube bn square cn plus d. So I think you can relate. You can relate now. Okay. And same for GP also, guys. GP also. If difference are in GP, then this is how we can write T equal to IR plus B. See, when it is a GP, what is Tn? A into R to the power n minus 1. When difference in GP, this is how you write. And if it is done, if it is repeating, you can write it like this. But this you can skip it, because in exams I have never seen problem from this side, this part. But from the difference series in AP, you are going to have it definitely. Okay, so you can take a screenshot, or you can write all the points. You can write all the points here. You can understand. You can like solve problems based on that. And we have also the example also you can relate it with it. So guys, that's all for this chapter, sequence and series. Whatever questions have been done in this session, do go through every single problem properly, and you are going to have a very strong hold on sequence and series concepts, because the questions are not difficult. Some questions have been lengthy but not difficult. Rarely, it's very rare that you will have a question which is complicated, difficult and calculative as well. Okay, mainly the method is simple, we just need some calculation steps. Okay, so in the next term, I'll be going for quadratic equation. Till then, keep solving whatever set of questions you have, or do PYQs also. I'm not going to take every PYQs. You can solve PYQs also. Keep learning. Best of luck.